Welcome to the stream. Okay, this is my first stream on this YouTube channel. Welcome you all to the FE Physics English Medium Math Supporting Seminar. Yeah, seminar. හරිද? හරි. දැන් ඔයගොල්ලෝ දන්නවා අද මොකටද ඔයගොල්ලෝ ඇවිල්ලා ඉන්නේ කියලා නේ. ඉතින් මේ අපි වැඩේට යමු ටක් ගාලා. So I think I can see your chat. Let me see that. මා පොඩ අලුත් මේ වැඩේට. Okay. Give me 1 second to check your to get your comment section. If you have any question, you can chat. Okay. හරි. යාළුවන්ට එහෙම ඉන්නවා කට්ටියට කියන්න. live chat එක. Okay, I can see that. හරි. එහෙනම් වැඩේට යමු. You can subscribe. එහෙමනේ සාමාන්‍ය YouTube වල කියන්නේ නේ. හරි. අපි වැඩේට යමු. So this is the English medium. If you are, I mean, if someone new, this is the English medium channel. If it is English medium platform, and I'm the one doing the English medium tutoring under the AP Physics. So if there is someone new, let me brief introduction about myself. I'm SHAN UPENDRA, and first class electrical undergraduate from University of Manitoba, from the Department of Electrical Engineering, and currently working as a tutor and supervisor in the FE Physics English Medium division. So today I'm discussing the supportive maths, or simply maths, trigonometry and basic mathematics for A-level physics students. So there might be a bio, maths, any person can get the idea about the the trigonometry, quadratic equation, graph. So let's discuss those things, and okay then. So let's start. I am only trig වලින් පටන් ගමු. හරි. මට ඇත්තටම ඔයගොල්ලෝ chat එක තමයි බලාගන්න බැරි වුණා. හරි live chat එක. If you have any question, you can ask through the channel. හරි. Okay. හරි කමන්නේ. වැඩේ කරන් යමු. එහෙනම් අපි ඉස්සෙල්ලාම trigonometry වලින් පටන් ගමු. හරි. Because we started vectors last week. We not last week, 2 weeks back we started the vectors, and because of that we need the simple calculation. We need to do calculation. We need to use trigonometry, tan values like angles. So let's start with the trigonometry and then continue with the other mathematical concepts. Okay, so trigonometry. මේ trigonometry කියලා මම එළවලු ඔක්කොම ගන්නන්නේ නැහැ. හරි. අපි කෙටියෙන් කියන්නේ trig කියලා. Trig. Okay, so when you take the trigonometry, what do you know about trigonometry in O levels? Hi, trigonometry. What do you know? So simply, when you take a right angular triangle, sorry. So here today I'm not giving any other PDF. You can create a note, take a A4 paper, or take a whatever paper. You can write down these things, because these equations, formulas you need for your calculation when you are doing the calculations. Okay, when you are doing the simplification, you need this. So here when you take a triangle, rectangle, you know, this is known as a rectangular triangle. The angle here is 90. Okay, so now when you take this angle, okay, so let's take there are 3 angles. So with whatever triangle, when you take whatever triangle, alpha, beta, gamma, when you take whatever triangle, there are 3 angles, alpha, beta, gamma. The addition of these 3, alpha, beta plus gamma, definitely 180. You know that. So the important thing, if you take a right angular triangle, you know this angle is 90. So if this is alpha, if this is theta, then you can write alpha plus theta plus 90 is 180. That means alpha plus theta is 90. If you need to represent theta in terms of alpha, you can write theta equals 90 minus alpha. We need this stuff. And then you know about there are different types of triangle, isosceles triangle. Okay, so isosceles triangle means two sides are equal. Isosceles triangle, this alpha, this one also alpha, these two sides are equal. And we have equilateral triangle, all the three sides are equal. All the three sides are equal, equilateral triangle. Then 60, this angle becomes 60, equilateral triangle. Okay, so I'm just giving you different types of triangles. So now we are focusing about the right angular triangle. Right angular triangle. So let me take this angle as theta. Let me take this angle as theta. Okay. So now we don't need these triangles. Let me put this one aside. Okay. So then I'm taking the right triangular triangle. So there are certain relationships which are important for calculations. When you take right triangle triangle, I can mark the these points as ABC vertices. I can mark ABC, and here another way to represent this one is B. The angle here I can write theta, or this is the angle of B. Okay, B is a point. This is the angle of B. You can write. You can mark like that also. Another representation. This is the angle of the C. Okay, so simply we can mark Greek letters for the angles. We can use the Greek letters also. So then relative to this angle, this one is AC, that one is known as opposite angle. This AC is the opposite angle, and then AB is the adjacent angle, and the BC is the hypotenuse. Okay, hypotenuse. You know how to pronounce it. So this is the ABC according to this angle. Relative to this angle, I can mark this AC as the opposite angle, AB as the adjacent, opposite side, and AB as the adjacent side. So then we have certain definition, sin, cos, tan. We can take sin theta, cos theta, and tan theta relationship. Sin theta means opposite over hypotenuse. Opposite over hypotenuse. Okay, so you can take hypotenuse, hypotenuse. There are several pronunciations, so it doesn't matter. You know this one is the hypotenuse. Okay, so sin theta x over z. Remember the sin. What is sin theta? Then cos theta. Okay, cos theta equals related to this angle adjacent over hypotenuse y over z. Okay. Okay, I think you can hear me. Hurry. Okay. So then tan theta. What is tan theta? Tan theta. So tan theta means opposite over adjacent. Opposite over adjacent. You know this stuff. Okay. So sin, cos, tan. Remember that? Normally, this relationship you can write. You can put a note. And when you take a right angle triangle, according to the given angles theta, I can mark opposite over hypotenuse as the sin theta x over z, and then adjacent over hypotenuse as the cos theta y over z, and finally tan theta is the x over y, opposite over adjacent. Then if you mark another angle alpha here, you can mark another angle alpha here, doesn't matter. Then relative to that one, your definitions are completely different. Okay, so then your alpha, sin alpha means relative to this angle, this is the opposite side, then opposite over hypotenuse, then sin alpha is opposite over hypotenuse, then y over z. Okay, so then if you want, you can write those stuff also. I can pen and then sin alpha you can write y over z. Then cos alpha equals x over z. Then tan alpha equals y over x. Okay, so you know these stuff. Hari, podi deval hari. Okay, so now remember this relationship, and it's a very simple thing. And now we have certain other definitions. If you take 1 over sine theta, 1 over sine theta, කවදා හරි ඕන වෙයිද දන්නේ නැහැ. මම තියාගෙන 1 over sine theta, that one is known as cosec theta. Cosec theta. 1 over sine theta means cosec theta. Okay, ඒ වචනේ හැට දැකලා පුරුදු කරගන්න. හරි, that's enough. Just get the vibe. I mean, sometimes in the whatever question, if you feel if there is a cosec term, that means 1 over sine. If there is a cosec theta, that means 1 over sine. Okay, so we have a definition cosec theta. We have definition cosec theta. Cosec means 1 over sine. So I'll subject the cosec theta. Cosec theta means 1 over sine theta. So according to the definition here, it becomes z over x. Z over x, but you need to know about this. What is cosec theta? In the A level or in the whatever exam, if there is a cosec theta, that means you can write that one as 1 over sine theta. Then we have another term, sec theta. Sec theta means 1 over cos theta. Okay, according to the definition, it becomes z over y. Z over y. Okay, z over y. Then there is another relationship, cot theta. Cot theta. Cot theta means 1 over tan theta. 1 over tan theta, that means that one is y over z. Sorry, y over x. Y over x. Remember the relationships. Remember the relationship. Write down those stuff. Complete the note. Yeah, then. I'm not giving that much time, but you can write down. You can write down. So use the Telegram group. It's easy for me to check if you have any question, because I'm not getting the what we call the live chat. So use our channel. Okay, use our channel. Channel means Telegram channel. Okay. So then, if you have any question, you can ask. Then there is important certain relationships. So when you take tan theta, tan theta can definition, we have definition for tan theta, and you can see that definition tan theta can be achieved by dividing sin theta from the cos theta. So remember that always tan theta can be identified sin theta over cos theta. So tan theta equals, so we can write tan theta equals always sin theta over cos theta. So tan theta can be written as sin theta over cos theta. Then cot theta actually it becomes like cos theta over sin theta. But cot theta equals cos theta over sin theta. 1 over tan theta, that means cos theta over sin theta. Cot theta. So now you can learn certain relationship, sin, cos, tan, and then tan equals always tan angle sin theta over cos theta. Okay. Remember that relationship. And then some other relationships, Harry, you can take here we know how to represent the theta in terms of alpha, or in alpha in terms of theta. Let's say there is a sin alpha value. I need sin 60 as example. Then that sin 60 definitely equal to sin 60. Okay, we can write sin 60 can be represented as sin 90 minus 30. Remember the relationship. Okay, so likewise we can, whatever angle, given angle can be represented as 90 minus other angle. Okay, so now let's take the relationship here. The coordinate relationship we know when you compare these alpha theta. So I'll take this mic lecture no need to derive. No need to derive. You can take a relationship. And මම කියන්නම් පොඩ්ඩක් පෙන්නන්නම් මෙතනදී. I'll show you. So we can write that sin alpha means sin alpha කියන්නේ sin 90 minus theta. Okay, sin alpha means sin 90 minus theta. And you identified sin alpha means y over z. Sin alpha means y over z. And here you can see cos theta also y over z. Sin alpha means y over z, cos theta also y over z. That means there is a direct relationship. There is a direct relationship. Sin alpha equals cos theta. Sin alpha equals cos theta. So sin alpha means sin 90 minus theta. So that means sin 90 minus theta equal cos theta. So alpha means 90 minus theta. So I told you alpha can be represented as 90 minus theta. Then sin 90 minus theta we can prove, or here you can see those two are also equal. Sin 90 minus means sin alpha equals cos theta. Okay. Likewise, if you take cos alpha, okay, cos alpha, that one you can represent as cos 90 minus theta. And then you can see cos alpha means cos 90 minus theta x over z. Here this also x over z. Then cos alpha equals cos 90 minus theta, that one equals sin theta. Sin theta. Very special relationship. Okay, that means whatever sin 90 minus theta you can represent as cos theta. Then whatever cos alpha you can represent, that represent as cos 90 minus theta, and then that one is sin theta. Can simplify it. And likewise for tan alpha can be represented as tan 90 minus theta. And then you can see when you take tan alpha is y over z. And that one equals cot theta. Tan alpha equals cot theta. Okay. So you can write tan alpha 90 minus theta equals cot theta. Cot theta. Cot theta. Or 1 over tan theta. Any relationship you need to remember those relationships. I'll summarize this one. So you can see I didn't prove certain relationships. So let's take a summarize. We can write a summary later. So you can just write the derivation. Actually, I derive, not derive. I can show you there are certain relationship like this. Right? There are certain relationships. Okay. So finally, the summary is when you take, so this is the like the proof. Now the proof actually this you can see here according to the definitions we can make those terms equal. And finally, the idea is, the final summary is, when you take like sin 60. Before going to summary, let's take example. So if you need sin 60, we can write sin 60 equals 90 minus 30. Sin 60 equals 90 minus 30. Sin 60 90 minus 30 means sin 90 minus 30 equals cos 30. Sin 60 equals cos 30 වෙනවා. Okay, according to this relationship, if alpha is 60, if sin alpha is 60, then that one equal cos 30, because 90 minus 30 is theta will be 30. So likewise sin 60 equals cos 30. If you take cos 60, then cos 60 equals sin 30. Likewise you can write. Then tan, let's take tan whatever angle, tan 30. Tan 30 equals cot 30. Cot 30 means 1 over tan 60. Sorry, 1 over, yeah, I can write cos 60. Tan 30 equals cos 60. That one equals 1 over tan 60. Likewise, you can write, just identify the relationship. The summary is, so this is the numerical calculation. This is just a numerical calculation. Right? This is just a numerical calculation. Okay, you can write this one here, just a proof and numerical calculation. The final summary. Metin proof. Just this is just a proof. No need to write this one. So write this. Definitely write this part. Definitely complete this one. These are some additional things. Okay, final summary. You need to write the summary. This is the summary. Okay, so we know sine, and then we know what we call what is sine, what is cos, what is tan. You know those relationships. Okay, so likewise, the other important thing is the relationship between those theta. Yeah, we can write sine. If there is sine 90 minus theta, if there is sine 90 minus theta, that one always equals cos theta. This is the final summary. If cos 90 minus theta is there, that one is always equal sine theta. If there is a tan 90 minus theta angle, that one will be equals cot theta equals 1 over tan theta. This one also very important. Final summary. Okay, complete this summary part. If you need, you can put that one also, doesn't matter. This one definitely you need to copy down. This one, I'll mark it. This section you need to mark on your book. Okay. So then, if that time is sufficient enough, then you can just take a session, complete it, or you can watch the video. I mean, you can rewind it. Okay, so now let move some not deep theories, but let identify certain relationships in these, I mean, between those terms. So we can, so I think you are familiar with the sine 60, cos 30 values like that. I'll give you a table, but before that, let me take an example. So now we are going to another proof. So I'm just writing here, this is that one, also not needed, just a proof. So let's take sine 30. Sine 30 value is half. You need to know that one. I'll give the table. Then cos 30 equals root 3 over 2. So let's take the square terms of that. So I'm taking sine 30 total squared plus cos 30 total squared. I would like to take the square terms. I would like to take the square terms. Then let's take the let's substitute the values. So sine 30 squared means half squared. Cos 30 squared means root 3 over 2 squared. Okay, I think you know that these are basic fundamentals. I may not liagan on it now, but you can, if you want, you can write. If you take AB squared, you can write A squared B squared. Some indices, theory related to the indices. A over B squared, you can represent A squared over B squared. Okay. Likewise here, I can add half squared means 1 squared divided by 2 squared. 1 squared means 1. Then this one is 4. So you whatever root value, so root means half value. Root means let's take 3 to the power half. This is 3 to the power half. So if you take 3 to the power half squared, simply you can take 3 half into 2. I mean, you know that. So we can take A, let's take A M N kill. If you take A M N, these are some theory related indices. Indices, if you want, you can note down, but these are some fundamental theories. You know, I think these things definitely you should know. AB squared you can write, A squared B squared, A plus B squared you can write, A square B squared, A, if you want to copy down you can, doesn't matter, A to the power M times, I mean A to the power M again to the power N, then you can write AMN. So here this one also something like that, 3 to the power half to the power 2. Finally this one becomes 3 to the power 1, half and 2 cancel out, so this one becomes 3. 3 over 4. Finally, this one equals 1. 1 over 4 plus 3 over 4 plus 1. So, like that, you can prove when you take sine same angle, sine theta squared plus cos theta squared, that one becomes 1. Remember that relationship is very important. So, another important thing. Okay, so now we know certain relationship like this. So, another important part. Okay. Mine happy maybe today. You can note, I mean, you can note down that special point. Just proof. Nice, okay, I mean, I'll just write the important thing here. Sine whatever angle, you can take, and here remember that if you take sine, I mean sine or cos, whatever trigonometry, you can write sine theta totally squared can be represented as sine theta squared. Sine theta squared. Sine theta totally squared can be represented as sine squared theta. Okay. So another way to represent it. So මෙන්න මේ ටික වැඩක් නෑ, මම මේ නිකන් අර දෙපැත්තෙන් ලියන්නේ, those things no need to copy down the main part. These are some proof. Okay, so in here you need to write down that one in your book. So then I can write this one also very important. What is the relationship? Sine squared theta plus cos squared theta equals 1. This is a very important relationship. Sine squared theta plus cos theta equals 1. Write down that relationship also. Here you can see there is a proof and the equation also given. This is the proof. Not a proof actually, this is a numerical example. So middle part you can copy down to your book. This is just a numerical example. So here this one, the idea is sine square theta plus cos square theta is always equal 1. If you divide the whole term by cos square theta, this is again a proof. But so here now we realize there is a relationship sine square theta plus cos square theta 1. So I would like to take another proof. Sine square theta plus cos square theta equals 1. I would like to divide the whole expression by cos square theta. Here this one also cos square theta. So then I can individually divide. Then it becomes sine square theta divided by cos square theta plus 1 equals 1 over cos square theta. That means this one becomes tan square theta. Tan square theta plus 1 equal, this one is sec square theta. Okay, so this is the proof, and here that one was another important relationship, not important but tan squared theta plus 1 equals sec squared theta. Sec squared theta. Here this is the proof, and this is the relationship you need to memorize, not memorize, yeah, memorize. Okay. මේ ටික දාගන්න ඕන පොතේ වටේ තියෙන නිකන් අර වැඩක් නැති රෆ් වර්ක් එක වගේ. Then another important thing, that one is known as සිංහල කියන්නේ බාකෝණ ප්‍රසාරණය කියලා. හරි. Half expansion. Like we can represent, so this one I'm not going to prove, but you need to remember. හරි. වලතියාගෙන මෙහෙම තියෙනවා. Sometimes we need 2, let's take sin 2 theta. Sin 2 theta. Sin 2 theta means like sin 60. Can be represented as sin 2 into 30. අවුලක් නෑනේ. Sin 2 into 30. I can represent sin 60 equals sin 2 into 30. Then sin 2 theta we can expand. Always remember that this is the 2 sin theta cos theta. 2 sin theta cos theta. I'm not going to prove, but if you want, you can just take a numerical example. Here, let's take sin 2, sin 60 equals sin 2 into 30. So then I can write 2 sin 30 cos 30. I'm taking a numerical example. So then 2 sin 30 means 2 into half into root 3 over 2. Cos theta means root 3 over 2. Then it becomes root 3 over 2. So actually sin 60 value itself is root 3 over 2 tamai. Sin 60. Sin 60 value actually root 3 over 2, but again using this relationship we can get the same answer, root 3 over 2. I just explained that we know sin 60 value is root 3 over 2, and using this sin 30 values and cos 30 values I can get the same answer. Sin 2 theta, this is 2 theta, okay, 2 theta, like 230, 2 into 30. Again cos 2 theta, cos 2 theta equals cos squared theta minus, okay, this is plus, this is plus, this is minus, sin squared theta. මේ ඔක්කොම ෆිසික්ස් කරන ළමයි දැනන් ඉන්න ඕන. හරි. නිකම් මෙහෙම ටිකක් තියෙනවා ලෝකේ මෙහෙම දේවල් තියෙනවා කියලා දැනන් ඉන්න. That's enough. Just remember these things are there, exist in this world. Math students, they are definitely, they know, I mean they need to know. But bio students also definitely they need to know some, at least an idea. Sometimes we are using this one. You can see the linear motion. I'm using this one to explain the maximum distance. So if you want to take the projectile motion to get the maximum distance, there is a proof. We are using this simple trigonometry part to do some calculation. Let's see. So 2 sin theta cos theta, we can, if there is a 2 sin theta cos theta, we can convert back again sin 2 theta. Tan 2 theta is not needed for you. So sin 2 theta and cos 2 theta is sufficient enough. Oh, this one is cos square theta minus sin square theta. මේ තව variations වගේක් තියෙනවා. හරි, but no need. So you can write using these two relationship, we can just take some another version of cos 2 theta, but no need like this. So we can write 2 cos, we can remove the sin square theta using this one, and then you can get 2 cos theta squared minus 1 or 1 minus 2 sin square theta. But for your level don't need, you can own that. Just remember the cos 2 theta can be written as cos square theta minus sin square theta. That is enough. That is enough. Okay, that's enough for the basic trigonometry equations. There are so many equations. If you want, you can check for I mean math students, they are learning all the trigonometry relationships, formulas. There are so many formulas like this: sin a plus b, cos a plus b, tan a plus b, and then likewise there are so many things. You can Google it, trigonometry formulas. If you really interested on that. Okay. Then so you can note down these things. That's enough for your level. Here the other things are just rough calculation to show you these things are existing. Okay, that's enough. තව මම ඕන කරන දේවල් ටිකක් කියන්නම්. හරිද? I mean for calculation you need these things. So I'll move to a new page. Okay. So now let's take there is a triangle. There is a alpha. හරිද? The alpha is given like this angle is given tan inverse 3/4. This alpha value is given tan inverse 3/4. You need the, let's take for a calculation, you need the sin alpha. How do you find that? Okay, so for a particular question, the alpha is given, the angle is given in terms of tan inverse. Okay, I think you know about that. So when you, another rough calculation, okay, so when you take tan theta equals, let's take x, tan theta equals x, this is an angle, this is an angle, and this tan is a tan or sin or cos whatever, that is a function which convert the angle to a what we called natural value or whatever real number. So this is an angle theta. So there is a cake factory. You are sending angles, and this is the cake factory tan or sin or whatever. Then here you can get a real number, whatever real number. Here this is an angle. When you send that one through this cake factory, finally you are getting real number. Like you are sending flour and then finally getting cake. This is the angle, this is a real number. So function is the tan. If you want to do the other way around, okay, if you are sending a real number කියලා කියන්නේ බය වෙන්න 1 2 3 whatever decimal point or whatever, I mean the whole number line can be considered as real numbers. Right? So real number 1 minus 1 minus 2 0 plus 1 whatever value, real number. This is an angle. So this is a cake factory which produce real numbers when you inject angles. If you want to do the reverse thing, හරි ඔගොල්ලෝ ඔයා වගේ හරි කෑම කනවා හැබැයි අපෝ finally you are not getting angles, but let's take there is another cake factory or there is another machine. When you send real numbers, this is the way to represent real number. Okay, මෙහෙම අර හොඳට represent කරන්න. This is the notation of real numbers. Real number IR නෙමෙයි මේ තියෙන හරි R, but normally we represent it like this. Okay, so this is a real number, and when you send that one to tan inverse function, these are functions. Okay, tan inverse function, then you are getting angles. Tan or sin or cos whatever, just use the tan, whatever, tan, cos, sin. If you send angle, finally you are getting real number. If you get the tan inverse, that means here if you subject the theta, what we can do, we can write just like like a division, not division, but you can just think like that. But you can write tan, how do you move the tan to other side, like something like this, but it's totally incorrect. So then you can write it's like tan inverse, but that's not a good explanation, but you can see it's another function, tan inverse x. So now you can see when you inject the real number, this one produce finally angles. Okay, ලස්සන දේවල් හරි මැක්ස් කියන්නේ. බයෝ කරන කට්ටියත් ඉගෙන ගන්න ලස්සන දේවල්. මැක්ස් කරන කට්ටියත් මේ ලස්සන දේවල් ඉගෙන ගන්නවා. කේක දේවල් ඉගෙන ගන්නවා හරි. එහෙම තමයි. කොමර්ස් කරන කට්ටියත් ඉගෙන ගන්නවා ලස්සන දේවල්. ආර්ට් කරන කට්ටියත් ඉගෙන ගන්නවා. හරි. ඉතින් අපිට එන්ජොයි කරන මැක්ස් කරන කට්ටිය එන්ජොයි කරන තියෙන මේව තමයි. functions. Okay. So then here the alpha equals tan inverse 3/4. So alpha somehow provided using tan inverse 3/4, something like this. So then what they are asking, sin value, you need sin alpha, cos alpha. How do you find that? So what we can do, we can write this one, you can convert this one again to tan alpha equals 3 over 4. Tan alpha equals 3 over 4. Tan inverse, then you can write here tan theta equals x now, then theta equals tan inverse x. Again, you can write, you can come back to this value. You can write again this previous function, tan function. Okay. මෙහෙ පැත්තට යන්න පුළුවන්, මෙහෙට යන්න පුළුවන්. ඒ වගේම මෙහෙට එන එක මෙහෙට යන්න පුළුවන්. Okay, so when you inject theta, then tan convert real numbers. So when you inject real numbers, finally you can get angle. So that's why this angle, this is the angle. So that angle somehow represented as tan inverse 304. So finally you can convert tan alpha equals 304. So then we can write sin alpha. If you want sin alpha, now we know the tan alpha. So we know tan alpha means opposite over adjacent. 3 over 4. 3 over 4 means 3 opposite over adjacent. And then what we can do, we can use the Pythagoras. You know what is Pythagoras? You know what is Pythagoras? So another supportive thing, or the Pythagoras principle. You know, if you are not familiar with the Pythagoras, but I think you know basic stuff. A hypotenuse, discard of the hypotenuse, AC squared. Or I'll take the symbols here. So I'm taking another right angle triangle. Theta, no need to put theta. Just write x, y, z. So x, y, z, and then you can represent x squared plus y squared equals z squared. This is the Pythagoras principle. Pythagoras principle. There are two perpendicular sides. The square terms of the addition of the square terms of the two perpendicular sides equal to the square root of the hypotenuse. There are two perpendicular sides. The square terms, I mean x squared plus y squared, the addition of those two equal the square root of the hypotenuse. So using that relationship, we can prove or we can identify. Okay, so we can take this one as z, then z equals 3 squared plus 4 squared equal z squared. Then if you want z, then you can take square root. Here there is a square term, I can take square root. Both terms square root. Then I can take z equals 3 squared means 9 plus 16 25, root 25 means 5. So then we can write sin alpha. So when there is a alpha, whatever angle given like this, if you need sin cos, then just draw a triangle and then you can identify tan alpha is 304. Tan alpha equals 304. If you need sin alpha, now you know sin alpha equals 3 over 5. 3 over 5. Cos alpha equals 4 over 5. Okay, for calculation, vector calculation also, we need the angle between two vectors. Then sometimes the angle is given tan or sin or cos, whatever. Then you can create another triangle like this and identify the all three sides, and then you can get all the sin, cos, tan values. This is Pythagoras principle. Okay. If you have any question, you can chat through the Telegram channel, okay? Because I'm not checking the live chat. Okay, so then you need to know about that. So let's take another example. Hi. Let's take another example. Calculation. You can take, here I'm giving an angle. So here let's take again tan, let's take tan value. So tan, the theta is given as tan inverse 12 over 13. 5 over 13. 5 over 12. 5 over 12, yes. Theta equals tan inverse 5 over 12. Now I need the sin theta values. So what we can do? අපි කැත උත්තරයක් දාමු, කැත එකක් දාමු. නැත්නම් ඔක්කොම ලස්සනයි. Let's take 5/10. So again you can simplify this one as ලියනවා 1/2. 1/2. I'll take 1/2 tan inverse 1/2. Theta equals tan inverse 1/2. කැත එකක් දාමු. So then theta equals tan inverse 1/2. That means this is 1, this is 2. If you take the tan theta, just draw tan theta. Tan theta equals 1/2. That means 1, this 1 and this side is 2. So then you can mark this one as 1 squared plus 2 squared square root. So square root of 4, square root of 1 squared plus 2 squared. So that one becomes 1 squared means 1, 2 squared means 4, 1 plus 4 means 5. So this side, actually that angle becomes, oh sorry, not that side, becomes 5, root 5, root 5, root 5. Right? Like root 5, you know. So that means this length is root 5. Right? Then I can write sin theta equals 1 over root 5. Cos theta 2 over root 5. If you need the sin cos. I am taking theta equals tan equals 1 over 2. That means tan equals 1 over 2. So then this is 1, this is 2, and this side you don't know. Then use the Pythagoras and identify that. 1 squared plus 2 squared, and finally you need to take the square root of that. So then that one becomes root 5. Finally, you can write opposite of hypotenuse and adjacent of hypotenuse as the cos theta. Okay, clear? Okay then. හරි නේද? Good. So now you know about the sine. How do you find the tan or sine or whatever angle if the given angle is given in this way, in this way. If the angle is given in this way, now you know how to calculate. So now let's take the standard trig table. Okay, so now I'm going to that table. First I'll write down that one with you, and you need to copy down that one with me, and then you can get the idea. Okay, so remember that. So there let's take first let's write down that standard, or usually you need to know about these common values. These are some common values. Okay, so now I'm going to represent sine, cos, tan. මට මේක ඕන print internet එක නම් දාන්න පුළුවන්, but I would like to write, then I can show you certain relationships. මෙහෙම තමයි මම තියාගන්න කියලා. Okay, so then so I'm also memorizing in that way. ඔයගොල්ලෙන් කාලේ අපි මතක තියාගත්තේ එහෙම තමයි. Right? So then what we can do, 0, 30, 0, 30, 45, 60, 90. Okay, so and also you need to somehow familiar with the radian values also. Radian මතකයිනේ අපි කතා කරලා තියෙනවා. හරි, you need to familiar with the radian values also, especially math students. Math students, you need to familiar with the radian values. Okay, not always the degrees. Definitely you need to get familiar with the what we call the radian values, radian angles. Hari. Okay, so let's create the table. Math table එක ගහන්න, then you know how to memorize this stuff, how to get a certain pattern. Sine, then 0, 30, 45, 60, 90. Okay, so here this is sine whatever angle, cos whatever angle, tan. Then I'm taking 0, 30, 45, 60, 90. That's enough. Those are the most important thing. 0, 30, 45, 60, 90. Okay. Sine 0. Sine 0, 0. And I told you that මොකද මම ඔන්න කිව්වේ මම ඉස්සෙල්ලා කිව්වා sin theta always equals cos 90 minus theta. Sin theta equals cos 90 minus theta. You know that, we learned that. Sin theta always cos 90 minus theta. And we know opposite also correct. Cos theta equals sin 90 minus theta. That direction also correct. And then I told you tan theta always equals sin theta over cos theta. This table is not that much hard if you know the relationships. So sin 0 is 0. Cos 0 is 1. So if sin 0 is 0, there is another angle which get the same value. Tell me that one. බලමු chat එක බලන්න. කොහොමද chat එක බලන්න? ඒක තමයි දන්නේ නැත්. Because okay නෑ මම අහන්නේ නැහැ ප්‍රශ්න. හරි. අපි වැඩේ කරන්නේ. It takes time also. Okay. So tell me, I mean, you can identify there is another angle which gives the same 0. What is that? Sin 0 equals cos 90 minus 0 is cos 90. Cos 90 also 0. Cos 90 also 0. Maka තියාගන්න පුළුවන්. ලේසියි. Sin theta always equals cos 90 minus theta. Okay. So let's take another one. Cos 0 is 1. Then sin 90 also equals 1. Because of the relationship. Then sin 30 is half. Sin 30 is half. Sin 30 is half. Then there is another angle. Which one? Cos 60. Cos 60 also half. You need to memorize these stuff. And then sin 60 is root 3 over 2. Root 3 over 2. That means cos 30 also root 3 over 2. Root 3 over 2. These are some common regular day-to-day life. We are using these 30, 40, 60. That's why we are memorizing these values. Otherwise, you can use the sine table, cos table. But no need if you know these values, because always, or most of the time, not always, most of the time we are using, or we need these values because the questions are given with these values. Then no need to check the tables. Okay. So then finally, sin 45 equals cos 45, 1 over root 2. So there are certain relationships you can memorize. So then you can easily memorize these things with these patterns. And the tan value, you can see tan is always sin or cos. So tan 0 means 0 divided by 1. 0 divided by 1 means 0. Tan 30 divided by, tan 30 means sin 30 divided by cos theta, cos 30. So then it becomes 1 over root 3. 1 over root 3. Then tan 45, tan 45 equals sin 45 divided by cos 45. That one becomes 1. Then sin 30 divided by cos 30, so cos 60, sin 60 divided by cos 60, it becomes root 3. Then tan 90 is sin 9 divided by cos 0, cos sin 9 divided by cos 90, cos 90 0. So what is the value there? So let's take, if you are taking 2 divided by 0.0, 2 divided by 1. Let's take 2 divided by 1. Key the value 2. 2 divided by 0.1. What is the value? 2 divided by 0.1 is 20. 2 divided by 0.01. What is the value? 200. 2 divided by, so likewise 2 divided by becomes 0.0001. That means that value is 2 in 10 to the power 4, 20,000. So you can see when you are getting close, this one, when you compare these values, this one is more closer to 0. You are getting closer to 0. So if you divide by the 0, then what's happening? 0 means 0.0000000 digital 0 thing. Continuous is going to 0. So whatever value divided by 0, it's infinity. Infinitely large number. You can see the pattern. When you divide by whatever value, whatever real number by small value, simply if it is get more smaller, then value becomes much larger. Okay, finally, if you divide by exact 0, then it's infinity. Infinity. It's infinity. Infinity. But 0 divided by 0, it's not defined. 0 defined by 0, not defined. Not defined. 0, there is no exact answer. 0 divided, 1 divided by 0, whatever constant divided by 0, it's infinity. Whatever constant divided by 0, it's infinity. But 0 divided by 0 is not defined. That one is not needed here. It's here it is infinity. It's infinitely large value. Infinitely large value. That's the relationship. Okay. So remember the table. You need to memorize these values. Okay. Harid, you can see the pattern actually. There are some similar values. You can remember that terms with these relationships. Sine 60 equals cos sine 30 equals cos 60. Sine 60 equals cos 30. Sine 45 equals cos 45. And these things are also similar. Then you need to complete this one. So why we are giving only for the this range? So let's take the standard tables. Let's take a standard table. So this is a logarithm book. So when you take logarithm book, we can see finally there are sine tables. Are sine tables. So you can see sine 30. Sine 30 means 0.5, half 0.5. Sine 30 means 0.5. Okay. So here again cos you can see this one maybe temporal cos, you know, when you there is a relationship between sine and cos. Sine 30 equals cos 90, cos 90 minus sine 90 minus theta equals cos theta. You can see here this is 30 and normally we are taking the cos value from the opposite direction. So you can see these values are for cos values. Maybe cos ticket. So you can see sine 30 equals cos 60. 0.5, 0.5. They are equal. Okay. So get the idea. Sine 30 always equals cos 60. And that standard value we can remember half. But when you use this book also, you can see these things are there. Okay, so if you need sine, let's take sine 20. So you can refer this book, and this is sine 20 value. This is the sine 20 value. Sine 20 value. Okay, this is the sine 20 value. If you need cos 55, cos 55. So then you need to always when you take the tan or sine, simply sine table, this value represent the sine, and this one the other corner which marked to the opposite direction, the numbers are marked in the opposite way, and that one is for cosine or cos numbers. Okay, so then cos I need 55. So cos 55 you can take this is the cos 55. Okay. Cos 55. This is 0 point something, 0 0.5736. 0 0.5736. If you need sine, so you know, if you need any degree, you know, this one is 50. I'll take an example. You know, when you take this one, 31 degrees, and then we have another set of values known as minutes and seconds. So in this table you can see these things are minutes, meaning so minutes are also indicated in this table, minutes. So we can go up to minutes also. That means 31, let's take, I need 31, 17 minutes. 31 degrees, 17 minutes. 31 degrees, 17 minutes. So what we can do, I need the sine value of it. I need the sine value of it. I need the sine value of it. So then the concept is I need to get sine 31 degrees 17 minutes. So I can check 31, this one, this row, then 17. 7 can the higher. And you can take 10. 10 means this one. Okay. That means you can take 31, 10, and you can take a 7 using this side. Here you can see you need to take 7 here. So 17 and then 10 plus 7. So 10 plus 7. So 17 from this column. So this is the number you need to use. So follow the exact column. Okay. So finally 31, 17. Then you can get this one is 0.5175 5175 plus you need to take the another 17 for this one. Okay, you need to add this one to this I mean this is 0.0 something, and so finally you can add these two and get the value 0.5192 ne? Okay, බලන්න 5 7 එකක් ඉතුරුයි then is 5192. So you can see the next one 31 32 32 is 0.5200 5200. I mean 32. So sorry, not 32, sorry, my bad. 3120. 3120. 31 degrees 20. 31 degrees 20 is 0.5200. Okay, so we are taking 31 degrees 17 minutes. So this is the final answer. Okay. So likewise you can have the sine table, and remember that when you use the sine table you can see only the values are there up to 90, 89, 89, 60 minutes. So this is 60 minutes. Sorry, 89, 60 minute means 89, 60 minutes. 89 degrees 60 minutes means again it's 90. So this is the one, you know, sine 90 means 1, cos 0 is 1. So here the values are only indicated, or values are all marked up to 90 degrees. So if you want sine 120, then what we can do? I need sine 120. I need sine 120. Then what we need to do? We need to use some relationships. Okay, we need to use some relationship. We'll see. Those things are known as circular quadrants. Circular quadrant. Remember that this table only include up to the 90. That means acute angles. Only the sine, cos, tan values are only given for acute angles. If there is any obtuse angle, you can't use this table directly. Then you need to have a certain method to convert, or you need to identify the relationship between the obtuse angle and the acute angle. So let's see. Okay, so tan value also same thing. This is a tan table. So now how do you get the sine 120? How do you get sine 120? Okay, so now we can move to the circular quadrants. Circular quadrants. Circular quadrants. So this is the concept. This one is known as circular quadrants. Circular quadrants. Okay. So when you take circular quadrants, simply before going to the circular quadrants, before go to the circular quadrants, Okay. Let's draw the sine cos tan graph. I told you sine is a function. Sine is a function. Sine is a function. When you mark the angle theta, okay, so when you mark the angle theta normally, this one is very important. Before going to circular quadrant, let's get this idea. So when you take angle, always if you measure the angle to the clockwise direction, if you measure the angle to the anti-clockwise direction, so normally we can take the, if you take the standard clock, analog clock, the standard direction of the index or indicators of that clock rotates. Normally we are taking clockwise. The second hand or the whatever there are indicators, no? So those indicators are rotated in a certain direction. That one is known as clockwise. Okay, so but here when you define the angle, that is standard. If you are measuring the angle to the anti-clockwise direction, with the x-axis, this is my x-axis or horizontal axis. Normally we are defining or we are measuring or we are marking the angle with the horizontal axis. If you are measuring to the anti-clockwise direction, that angle is defined as positive angle. If you are measuring to the anti-clockwise direction, that one is known as positive angle. If you measure with the horizontal, if you measure that one to the opposite direction, then that angle is known as negative angle. Negative angle. If someone marks negative 30, that means you with the horizontal, that one is minus 30 to the opposite direction, clockwise direction. So this is clockwise. So remember that. So negative angle is nothing but measure to the clockwise direction. Otherwise you can't simplify, or you can't apply this concept to the questions. So if the angle is measured to the anti-clockwise direction, then that angle is known as positive angle. If that angle is measured to the clockwise direction, then that one is known as negative angle. Okay. Before go to circular quadrants, we need to know that. Always remember that. So then remember the concept, with the horizontal we are measuring. That is the standard we are taking. So then you can see if you take the xy axis Cartesian plane, I can mark, let's take that I can take the total angle. I can measure the total angle up to 360. You can take here 30, then 90, let's take 120, then 180. This is 180. Then you can, those stuff. We can just rotate the vector, we can rotate the direction, or there is a vector, or there is another whatever plane. I can rotate that. I can rotate it. So this angle, remember the concept, this angle you can rotate around this one, and then you can see here this one is acute angle, this one is acute angle, this is acute angle. You can get the maximum, acute angle maximum 90. Okay, so this is 0, theta here 0, here theta is theta, this is 90. And then you can go for any other sections, like this one is we can say 120 obtuse angles, 120, then 180, this is 180. I'm marking in degrees. I can mark in radian also, but doesn't matter. Let's take up to this, let's take degrees here still first. So then 270. Okay. Likewise, you can take whatever angle, then finally this is 360. If you take one full rotation, if you measure the total angle here, that one is 360. You can measure beyond 360 also. We can measure, if you take another revolution, then that one is 2 complete revolution, means a total angle rotate So let's say there is a rotating device. There is a rotating device. If it rotates 2 revolutions, 2 rotations, then you can consider that total rotational angle is 320. 360 දෙකක් කරගුණා. 360 720. Likewise, you can take whatever angle like that. They also have obtuse angle. Remember the relationship. This is acute angle, then 90, 100 to 180. Then you can go for any 240, 270. Likewise, you can get whatever angle. So if there is a complete revolution, this is 360. Okay. So if you want to mark 400, 400 means something like this. 400 means මෙහෙම ගියා මෙතනට ආවා. ඉන්න මෙහෙම. So this is 360 plus another 40 degree. So now that one is still in the first quadrant. Again, this one is known as circular quadrant. This is first quadrant. Now this one in this area, this region. Your angle, you can mark that position of that rotating device is now in the first section. Okay, this is 400 degrees. You can take the total angle here is 400 degrees. Okay, likewise, you can get whatever angle, doesn't matter. So remember the concept. Here I just want to tell you that here we can, with the horizontal, this axis, you can measure whatever angle if you measure the opposite angle, if you measure the opposite direction. And let's say there is something like that. මෙහෙම තියනවා හිතන්න. And let's say there is something like this. මෙහෙම තියනවා කියලා. So then I can mark with the standard definition. This is the angle. This angle you can take as example, let's say 300. This is 300. Or else I can mark this one is minus 60. To indicate the same position of the rotating device, I can use that one is 300 degree, okay, 300 degree, or minus 60. Remember the concept. So here there is a rotating device. If it is in this one, you can take this, let's say as example 60. This is 0, 60, 90, 120, 180. Then we can take 270, again 360. And if you take other revolutions, then you can get another 400, whatever. Okay, remember that. You can measure like that. Okay. You can measure the angle 0 to infinity. Angle also you can always, there is no, the angle is not, I mean you can't say the maximum angle is 360, but when you take one circle, one rotation, then that one is 360, you know, but you can take the angle like that up to the infinity again, angles. So I told you there are several angles like this, 0, 90, 120, 180. So there are so many angles. So if you take that whatever angle, and I told you sine, cos, tan, those are functions. Functions can, like, there is a machine. That machine, if you send that angle through the machine, finally you can get a real number. Okay, you can get a real number. So then, no need to draw this one. Or something like this. We can measure the, you can take this one as 400. Sorry, my bad. No C here, because sometimes we are using Celsius. Sorry. This is 400 degree. This is 40 degree. This part. Okay. So I can write 360 plus another 40 is total angle 400 degree. This is 300 degree. I can mark minus 60 or 300. Okay. So maybe I can take something like this. Then I can take this one is 120. Acute angle. 120. Likewise, you can mark whatever angle you can mark. You can represent 240 obtuse angles. Acute angles also you can mark. Here you can mark if you want minus 120. So this is acute angle, plus 60. kelimah plus 60. This is plus 120, plus 240. This is plus 400. Or we can mark again the position is equals plus 40. Plus 40. Here it is plus 300 or minus 60. Okay, so likewise you can mark the angles. So then you can see, this is very important. So you can see when you mark the theta axis, when you mark the theta, this is the angle theta. This is the function of sine. I am taking sine function. Sine function. Or you can see sine theta. So when you take the sine graph, this is the standard graph. This is standard graph. Sine theta variation is something like this. So here you can see, I'll mark the known angles, 90. Then we can take 180. Then 270. Again 360. This is one full rotation. It can continue continuously. So then when you plot this 90, we know that one is 1. Then 180 again, that one becomes 0. You can see something like this. This is the final graph. This is a sinusoidal graph. This is a sine graph. Remember the variation. It's not a semicircle. It's not a semicircle. It's a sine graph. It's a sine graph. Sinusoidal waveform. Okay. So always remember that this is the theory. You can continue this. This one is continuously repeating the same thing. I told you this again 400 means like 40. So you can mark this is something like this. This is the sinusoidal waveform. This one is known as sinusoidal waveform. Sinusoidal waveform. This is the part of that. This is the part of that. This is the part of that. 0 to 360, I am taking a part of that. Okay. So if you want to mark in radian, this one is 2 pi. You know the angle radian. We discussed that on it in the class. Okay. So you know 2 according by definition radian, the total angle is 2 pi. 360 equals 2 pi. Okay. So then you can see this is 2 pi if you want in radian. I'll keep that one is in degrees, but you can mark this one is 2 pi. This is pi. This is pi by 2. This is 3 pi by 2. But in physics normally you can convert that one in your mind. If the angle is given in radian, you can convert that one into the degrees. I mean, you know the relationship. 180 degree equals pi. Remember that relationship. This is in degrees. This is in radian. This is in degree. This is in radian. Maths these are physics. Still physics. I mean, I'm teaching physics related. I mean the maths related to physics. So this is the sinusoidal waveform. I'm taking a part of that. Maths කරන කට්ටියට මේ වුණොත් මේවා නෙමෙයි ඉගෙන ගන්න ඕගොල්ලෝ හරි. You can see when you are learning trigonometry, we are going more deep. You are going more deep. So then this is the part of that. So you can see it's always there is a maximum. You can see the sine when you take sine whatever angle. Sine whatever angle. Let us sine 2 theta. That one also whatever angle. Sine 2 theta minus 1. That one also whatever angle. Sine එක අස්සේ කවුරු හිටියත් ප්‍රශ්නයක් නැහැ. Sine whatever angle, there can be anything inside that function. There is a function. Okay, remember the concept. Remember the concept. So it's sine 2 theta or sine 2 theta minus pi by 6. Okay, then sine just theta. All these things inside the sine. This is inside the sine. Inside the sine. Inside the sine. So if there is a whatever angle inside the sine, sine as a term, the maximum value it can get is 1. Maximum value it can get is 1. The minimum value it can get is -1. This is -1. This is 0. You can see here also is always oscillating between plus and -1. +1 and -1. Remember that. Remember that. So you can see sine whatever angle. Remember that. So let's take 2 sine whatever angle. Then this graph is doubled. If you multiply it by 2, sine theta again multiplied by 2 means you are getting something like this. Okay. If you take sine squared, then it's different one. Sine squared. But I am taking sine, but inside that one there is a whatever angle, doesn't matter. But there should not be any square terms or multiplication like this 2 or 3. Then this one is multiplied by again the same factor. So remember that sine whatever angle, doesn't matter what's happening inside. Sine whatever angle always greater than -1, greater than or equal -1, less than plus 1. This is the range of sine. This is the range of sine. Theta is the function, theta is the angle. You are sending that one through the cake factory. Finally, you are getting a real number. That real number is always in between plus 1 and -1. Plus 1 and -1. Plus 1 and -1. ඕන එකක් තියෙනවා එහෙම. There can be negative angles also. sorry මෙහෙට යනවා. මෙහෙම යන්න පුළුවන්. ඒක එතන පටන් ගන්න බිඳුවෙන් නෙමෙයි. I told you negative angles තියෙනවා පුළුවන්. I told you how do we get negative angles? You are measuring the opposite direction. You are measuring the opposite, then it's known as negative angle. Then it's known as negative angle. This is a sine function. This is angles. 90, 180, likewise. This axis angle. This axis angle. And this is the sine. So I am taking the basic version of it. I am taking the one repeating pattern. So I am isolating one repeating pattern. So you can see +1 -1 is in between +1 and -1. And you can see when you take whatever sine 30, there is a equal value in here. You can see when you take this value, maybe 30, let's take 30, there is in between 90 to 180, that is obtuse angle, there is a similar value. Make symmetrical. This is symmetrical. This one is symmetrical around the x-axis. I mean theta axis. And here you can see when you take whatever value here, 30, there is a sine 30 value. Sine 30 value will take half. And the same value can be obtained for a certain angle in between 90 to 180. Minus magnitude. If you have magnitude, that same value is occurred for a value in between 180 and 270. So you can see there is a pattern. So you can see if you take whatever obtuse angle, there are several angles provide the same magnitude. Just forget the sign. Same magnitude can be obtained for different obtuse angle if you know the acute angle variation. The concept is, I told you that there is a certain pattern. So in the sine cos tables, they are only providing this value for 0 to 90. If you need any other sine, you need sine 240. If you need sine 240, that one is not there in your table. But there are certain relationships. You can see sine 240 again somehow provide a value which is in this range also. Sine 240 value then I will let it sine 210, sine 210, then sine 210 value again can be identified. The same height can be identified using sine 30 actually. The idea is මේ තියෙන value වල මම සිංහලෙන් කියන්න. හරි. මේ තියෙන ඕනම obtuse value එකකට ඒ value එක ගන්න පුළුවන් acute angle එකක් ඉන්නවා. Because of this symmetrical distribution, symmetrical pattern, You can see here also, if it is 30, there is another there is another angle which provides the same sine value. Here also there is same magnitude. Here also there is another angle which provides same magnitude, not the minus, but same magnitude. So remember that. So if you want sine 210, you can get, or you can identify that value using the relationships. So there are certain relations you need to identify. And the relationship gantu. So now I'm going to teach you the relationships. So always remember that when you take any obtuse angle, you need to identify the correct relationship with the acute angle. You need to identify the correct relationship with the acute angle. So there is a pattern for that. So now I'm going to teach you the pattern. When for sine, I mean, so for 0 to 90, for whatever sine or cos or tan, we have the table. We have a table. You can use that table to get the value. But for any other obtuse angle, you don't have that kind of table. So you need, but for whatever obtuse angle, there is a relationship, or you can identify the value of the sine cos tan using the correct relationship between the acute angle. Acute angle එක sine එකත් එක්ක මේකේ value එක සම්බන්ධයක් තියෙනවා. අපි බලමු. So this is the sine variation. මතක තියාගන්න, this is the sine variation. If you need cos variation, මේක ඇඳ ගන්න ඕන. You need to draw this one definitely. Cos relationship. මේක ඇඳ ගන්න ඕන. Sin theta. Sin theta. Then cos theta also similar. That one is, I told you, sin theta always equals cos 90 minus theta. Or we can take the opposite. We can write cos theta equals sin 90 minus theta. Right? Cos theta equals sin 90 minus theta. May waveform එක මෙහෙට shift වෙනවා. 90 minus theta. Because of this, and this is 90. So because of this, cos theta variation can be obtained by shifting this one little bit to the left side. And මෙහෙම graph එකක් තමයි එන්නේ. For the cos theta. This is a sinusoidal. මේකට කියන්නේ මේ නම කියන්නේ sinusoidal waveform. Sinusoidal. ඉස්සරහට අහයි හැමතිස්සම physics වලදී. Sinusoidal waveform. This one is repetitive waveform. Along the theta axis. So theta can be, I told you, theta can be whatever value. It can go from negative infinity to plus infinity. But always the sine function provides the values in between +1 to -1. The maximum you can get +1, minimum you can get -1. Okay. So minus angles means you are measuring the opposite direction. Still you can get sine cos values. So now cos theta is somehow similar, but little bit different. It's shifted. The previous graph is shifted. මේ graph එක මෙන්න මෙහෙට තල්ලු කරන්න. Then you can get by 90. By 90 degrees you can shift it. So then you can get something like this. මේක මෙහෙට shift කරන්න. මෙන්න මේ part එක තමයි ඉතුරු වෙන්නේ. හරි. You can get this one. This is the cos graph. Cos. This is the cos relationship, cos variation. So I'll mark the angle 90, 180, then 270, and finally 300. I'm taking one repeating cycle. So then you are getting finally something like this. Okay, this is the cos variation. This is the cos variation. The same previous graph is shifted forward. So then this one is +1, again this one is -1. So your cos variation is also varying in between +1 and -1. This is for one repeating pattern. If you take the continuous repeating, you can see something like the same variation. කලින් වගේම තමයි. You can get something like this. Okay, so remember the variation. So here you can see when it is 0, you can get the maximum. Here when it is 0, it's 0. When theta equals 0, sine theta 0. Here when theta equals 0, sine cos theta is maximum 1. Okay. මේ හැඩයම තියාගන්න. මේ හැඩයම තියාගන්න ඕන. හරි, you need to remember that. You need to remember that. මේවා තමයි ඕන. හරි, physics වලට මේවා ඕන. මේවා නැතුව බෑ. You need this stuff. Because you need to know about the graph also. Sometimes we can see some in the exam they are asking you need to derive an equation. You need to derive an equation. Finally, you are deriving something like this. Let's take as example y equals x x cos theta plus 1 cos theta. Let's take y equals sine x plus k. You are getting something like this. Then you identify, if you want to identify the correct answer between y and x, that one has a sinusoidal waveform. Sometimes you are getting f equals mg cos theta. So then your force is varying. If you change the theta, let's take mg is a constant, and if you change the angle, they are asking what is the variation of the force. Friction friction. So then it's a cos theta variation. It's a cos theta variation. Okay, so you need to remember that. So remember the cos theta variation. Remember the sin theta variation. So those things are important when you are dealing with the questions. Past papers LL physics. I'm talking about the physics, not the combined maths. Bio කට්ටි බාපෝ මේ වෙන මැත්ස් ගොඩක් කියලා දෙන එහෙම හිතන්න එපා. එහෙම හිතනවා නම් තාම මැත්ස් කරේ නැහැ. හරි. You can ask that one from your maths friend. How hard they are, how deep they are going to the trigonometry. මාස ගණන් ඉගෙන ගන්නවා. So this is just a basic introduction, which is important for the physics also. So this is the cos relationship. This is y equals cos theta. This is the theta. Or later this is x. You can put x also here. This is x. So I can write this is x and this is y. It's cos relationship. So I'm taking a part of that. This is 0. This is 360. So I'm taking a part of that. Okay, I'm taking the part of that. So get the idea. This is the cos relationship. කම්මැලි හිතන ඔයගොල්ලෝ ඉස්සරහට කවදාරි YouTube එකේ තියෙනවනේ බලන්නකෝ. ඕන උනාම දැන් හිත හංගින්නකො නැත්තම් ආවපාරක් බලන්න ඒගොල්ලන්ට. Then I'm asking you to watch it again. If you're not getting that question, I'm not repeating in the class. I'm asking you to watch that one again, because I know, because according to the way that you're asking, I know the problem is not with the physics, problem with the simple maths. Then ඔයගොල්ලෝ ප්‍රශ්න අහනවානේ. So according to the way that you're asking, I know the question is not the physics problem, it's a simple mathematical problem. Then I'm asking you to watch this again. එහෙම වෙන්න පුළුවන්. So get the idea today and complete a note. So now you can realize the simple trigonometry principles. So this is a cos theta variation. You can see cos 0 is plus 1, cos 90 0. If you take the cos 180, cos 100 is minus 1. You can see cos 100 is minus 1. Cos 180 is minus 1. Okay. Cos 180 is minus 1. You can see with this variation. So then again, whatever cos relationship, same thing like the sine, whatever cos relationship, whatever, actually මොකක්ද තිබ්බත් කමක් නැහැ. But there should not be any constants like 2, 3 එහෙම තියෙන්න බෑ. That one should be greater than minus 1 and less than plus 1 again. Same thing as the what we called sinusoidal waveform. Okay, so if you try to plot the tan comes in nothing. It's not like this case. Tan can go up to infinity also. But if you want, you can better. This is a tan theta variation. This is a tan theta. It's totally different one. So we learned that when it is getting to 90, tan value is getting to the infinity. So those things you can't mark. You can't mark the infinity here. So those things are known as asymptote. 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 Any spelling? Asymptote. Give me 1 second. Yes, asymptote. Asymptote means you can't prove. I mean, you can't show that it's going to the infinity. So we can mark some straight lines like this. Mark. So remember that terms. So those are also important. Asymptote. Asymptote. So you can mark certain straight lines. So this is 90. So then again 180. Then again 270. 360. Again 270. There is asymptote. I'll show you. This is the variation. Again 360. So I'll mark minus 90 also. This is minus 90. This is minus 180. Okay. So then this is the variation. So when it is getting to the 90, we know tan 0 is 0. Tan 0 is 0. Tan 0 is 0. That's okay. That's no problem with that. Tan 0 is 0. Okay. Tan 0 is 0. Tan 90. Tan 90 is infinity. Tan 90 is infinity. That means you can't mark that one infinity. You can't mark the infinity. So what we can do, you can mark a straight line and represent that one. No, a straight line. This is the asymptote. And you should not touch that. You should not touch that. We can say these two contact at the infinity. These two are parallel. This is the straight line asymptote. I'll draw a straight line using the tools, then it's easy for me. So these are the asymptotes. These are the asymptote. AC okay, now spell කරන කට්ටිය ඉන්න asymptote කියලාත් කියනවා. Okay. So this is another asymptote. So this one when it is 0, you know, when it is 0, that one is getting to the 0. But when it is 90, that one is getting to infinity, but you can't mark the infinity. So what we can do, you can just connect, you can prove, or you can just mark closer to the line. You can say those two meet at the infinity. And then start from the negative infinity. When it passes the 90, starting from this point, graph again. This is the tan variation. You can just Google it and find the correct variation, something like this. Okay. So if you want to identify the graph, again, the graph you can use GeoGebra. I'll show you. I mean, for the learning purpose. If you want to identify the correct variation of a certain graph, you can use the GeoGebra. Okay, so this is the tan variation. So it's starting. So you can see this one goes to plus infinity, and here is this one is coming from the minus infinity. Minus infinity. This is the infinity sign. This is the infinity sign. Okay, and again that one goes to plus infinity. Again, from starting from this end, you can see this is the one. What we call variation pattern. We can draw asymptote and mark it. So this is the variation of the tan. This is the variation of the tan. These are known as tan curves. Tan curves. Tan variation. Okay. So again you can mark the pattern. Just draw this one on your book. This is a tan variation. I'm asking small thing. So this one is again start from minus infinity. Again go for positive infinity. Here you can get that is the variation. This is the variation. Okay, tan variation. So these lines are known as asymptote or asymptote because you can consider these two are meeting at the infinity. The line can asymptote. Asymptote asymptote or asymptote doesn't matter, you can pronounce it correctly. So because of that variation, your tan theta can be negative infinity or plus infinity, whatever value. Tan theta. Tan graph, you can get whatever tan value in between negative infinity to plus infinity. Tan එක ඕනයක් එන්න පුළුවන්, not limited in between plus minus 1. Here it is negative infinity plus infinity, whatever value. So this is a tan graph. Sine graph, cos graph, tan graph. පස්සේ දවසකට ඕන වෙයි හොඳේ. අදනේ ඉතින් මට එකපාර කියලා දෙන්න ඕනේ. So you can see when you take the logbook, tan graph tan එක. So you can see here when you take the sine always 0 point something, 0 point something, 0 point something. But when you take the tan values, so 0 point something, then you can see it goes to 1 point something, infinity 2, 3, 4, 5, 12, 171 infinity. Infinity. It's continuously increasing. This 300, you can see 89 degrees 50 minutes. 89 degrees 50 minutes. Its value is 343.77, and then this one is infinity, huge value, 90 degrees. That's why it's not marked. Infinity mark. This one is infinity, very large value. But in your sine cos graph, always you end up with 0 point something, 0, because it's always in between 0 and 1. Acute angle 0 and 1, 0 and 1. But when you take negative, when you take whatever angle is between minus 1 and plus 1, only the, I mean here when you take this one, if you take 0 to 90, if you take 0 to 90, that one is always positive. 0 to 90 in between 0 to 1. If the sine theta is acute, if this one is acute, then your value is always in between 0 to 1. Or acute. Acute can sulu kone. Acute. For acute angle, always it's in between 0 to 1 millimeter. But for entire range, it's end up with the negative answers also. Okay. Hari. Then අපි යමු circular quadrants වලට. Now you know about the sine cos. So you need to draw this sine graph. I told you that. මේක ඇඳ ගන්න ඕන. Sine and the range of the sine. And if you want, you can write the acute angle range is 0 to 1. Acute angle range, acute කියලා ගත්තොත්, that means in acute කියලා කියන්නේ 0 to 90. The angle is in between 0 to 90. Okay, the angle is in between 0 to 90, that is acute angle. (0 to 90). So then for acute angle, sine theta always in between 0 to 1 for acute angle. For acute angle, it's in between 0 and 1. Okay. So then cos and finally tan. මේ අමාරු දේවල් නෙමෙයි. හරි අමාරු අම්බෝ වද මොනවද මේ කියලා දෙන්නේ. පොඩ්ඩක් ඔළුවේ දෙන්න එහෙම පුළුවන් මම පොඩ්ඩක් අහන් දැනන් ඉන්න ඕන හරි. This is the tan graph. You can see here it is going starting from 0, it's going to the infinity. Then when it is 91 or when it is 92, if it pass the 90, starting from negative higher value, and then it's reaching to the 0 on the 180 degree point. 180 degree point, it's 0 again. Then again it's going to the positive side. When it is 270, it's again plus infinity. And if it is past the 270, again starting from negative infinity, it's continuously passing like that. If you want to real time watch this, real time can okay. For any graph, if you want to identify the variation of it, go to the Google. There is a mechanism, there is a way to plot this graph. You can use GeoGebra. GeoGebra. Okay, so you can use GeoGebra graphing calculator. There is a separate tab. You can use that one directly. So let's take I need y equals sine theta. I can get the y equals sine. So you can type that. Then plus sign you can input it. You can input. I need that for all the functions are there. I need y equals I don't need this tab one. How do you remove it? Keyboard I need to remove this keyboard. Okay. Okay. Y equal y aren't I? Okay. Y equals there is a problem with this keyboard, I think. Sorry for that. So you can take that y equals sine theta කියලා ගහන්න පුළුවන්. Type කරන්න ඕනේ නැහැ. There are functions. But you can see there is a keyboard, okay? So here go to function, then apply sine. Again you can get the theta sine x කියලා ගමු අපි. You can use here x හොඳයි තියෙන්නේ. So you can put y equals sine. පොඩ්ඩක් මේකෙම keyboard එක ප්‍රශ්නයක් වෙනවා දැන්. Okay, y equals sine. In your mobile phone, mobile device, you can do that one easily. Make me pen එක අවුලක් pen එකේ ගහන්න type කරන්න අමාරුයි. I'll show you that one through my laptop. It's easy for me. Then I can type it easily. Chrome එකට ගියා. You put the GeoGebra graphing calculator. You can type y equals sine x කියලා ගමු. Sine x. I'll share my screen. You can see now. Pain on it. So you can see here I insert the y equals sine x. So this is the graph, okay? Y equals sine x. Okay, so if you take tan, I need to input, let's take tan. Tan කියලා type කරන්න පුළුවන්, tan, or else you can get the function here. Okay, so I'll erase it. So tan, let's take here you can see the x-axis is you need to type that one as x, then enter. So this is the tan x variation. I brought and they color. So this one, these things also they mark in. You can assume this one is in degrees. Okay, they are giving the variations only. So this is the tan x variation. Axis එකකින් හිතන්න එපා. Just think this is a variation. Okay, so likewise you can get whatever graphs. ඉස්සරහ අපි graph ගැන කතා කරන්න මම අද ඉන්නේ. So then you can take y equals x graph, y equals x. Then if you take y equals x squared, පොඩි කයි ගෙන ගන්න x squared, x squared, x squared. Then this is the x squared variations. So let's take, I need the, you know that y equals sine x, this is y equals sine, but this is y equals sine x. Let's take, if you double it, 2 sine x. So then you can see here now the maximum value is increased. Now is 2, it's not 1. You can take the y-axis. That means now the sine x is multiplied by 2. Sine x is multiplied by 2. So likewise, I told you that if you take now, if it is sine square, the different one. If the sine square term is a different variation. So likewise, there are different ways, but you don't need to know about those variations. Just remember the sine x, cos x, tan x. So if you take cos variation, this is a cos variation. So here the maximum is occurred at the 0, and then this is the variation. So you can take all these things using the GeoGebra. It's a free tool you can use. Okay. So again, let's come back to the lesson. බලන්න දැන්. හරි. Okay. So this is the tan variation and the sine and cos. හරි. දැන් අපි යන්නේ ආපහු කතා කරන්න මොනවටද? Circular quadrants වලට. Circular quadrants. මේ ගොඩක් වැදගත්. හරි. අහගන්න ඕන හරියටම. You need to learn about these circular quadrants. So when you take circular quadrants, this is the concept I told you. When you take the acute angles, there is a book, there is a table for that. You can find the whatever sin 30, cos 30, tan 30 or sin 45. But you can remember those values because those are most the common terms, common angles we are referring. But let's say you need sin 31, sin 42. Okay, then you need to use that table. So then here if it is, I mean, normally when you take the circle, this is a circle, full circle, you can divide that circle into 4 pieces, 4 quadrants. I become 4 quadrants. So let's take one, this is one circle, I can divide the circle into 4 quadrants. 4 quadrants. So let's take this is 0, this is 0 axis, horizontal axis, and this angle is 90 degrees, 90 degrees. This one is 90 degrees. What is this axis? මේ පැත්තට තියෙන කීයද මේ value? This is 270, sorry 180. 180. This angle is 180 නේ. This is 180. Then this one is 270. You can divide that whole circle, one circle, into 4 sections. So this section is known as first quadrant, second quadrant, third quadrant, and the fourth quadrant. 1, 2, 3, 4. 1, 2, 3, 4. There are four quadrants. There are four quadrants. Remember the idea. So when you take these four quadrants, you know if there is a whatever angle here, if there is a whatever angle here, you know the theta. If you take theta here, we can say whatever angle sine theta, cos theta, or tan theta, whatever relationship, trigonometric relationship, all these things are positive. All positive. If you take acute angle, remember the concept. This is a pattern, okay? So I am not going to derive it. So here you can see if you draw a triangle here, if you draw a plot triangle, you know this one is x coordinate, y coordinate, this is x coordinate. This is a y coordinate, this is x coordinate, and this is the z. That one is a you know how to calculate that one, x squared plus y squared the square root. So when you take z, z is always a positive number. If they are hypotenuse, that one is coming from a square root. I mean, you are taking two, let's take minus, this is plus value, this is plus value, and when you take the square terms, remember that concept, okay? So when you take 2 squared, that one is 4, minus 2 squared, that one also 4. When you take minus squared, that one also gives a positive answer. Minus squared also gives a positive answer. Minus 2 squared also gives a positive answer. So then this is x, this is y, and then z is square root of x square plus y square. Definitely z is a positive one. Here in this case y is a positive one, x is a positive one. Then when you take a sine, cos, tan, whatever value, positive one, positive answers. Here when you take a triangle here, when you take a position here, a triangle here, okay, in this side. So this is, we'll take the coordinates xy, xy coordinate, you know this is a negative x, positive y. When you take coordinate of this one, you know this one is a negative value. This is a positive value. Okay, but here z, negative squared plus y squared square root. Again, this one is a positive. This is a positive. Okay, so when you mark angle here, when you mark an angle, acute angle here, triangle. If you mark a triangle here in this side, then definitely what's happening? Definitely, when you take the sine means opposite of hypotenuse, that one is positive. Y is a positive, Z is a positive. Cos value, cos is a negative, hypotenuse is a positive. Then cos is a negative value. You can say here if you mark, if you take angle in this quadrant, if you mark angle in this quadrant, then your sine is positive, but cos means adjacent to hypotenuse. Adjacent is a minus coordinate. It's a minus coordinate. This is a positive one. So because of that, your cos value is minus. Tan value, tan is adjacent to hypotenuse. That one also negative. That one also negative. So then you can say here, if you mark an angle in second, if you mark a triangle, and if you try to take that whatever what we called sine, cos, tan trigonometry term, you end up with positive sign, but all the cos, tan. Give me 1 second to erase this one. Okay, so I need to erase this line. Can't we? Okay. So here, when you mark whatever angle in the second quadrant, remember that your sine value, whatever means it's in between 90 to 180. Then it's sine is positive, cos is negative, tan is negative. Tan is negative. Likewise, when you take the third quadrant, you can see when you mark a triangle here, your x coordinate also negative, y coordinate is also negative. This is positive side, this is negative side, this is y positive, y negative. Your coordinates are both negatives, but your hypotenuse is still positive. I told you, when you take this kind of calculation, x squared plus y squared doesn't matter. These are, although these are negatives, when you take the square terms, it's positive. Mega positive, square root also positive. So because of that, when you mark the when you mark any angle here, when you take the sine cos angle here, your sine is negative. Sorry, sine is negative, cos is negative because opposite over hypotenuse is negative. Tan y is negative, x also negative, negative cancel out. Then tan is positive. Tan is positive. You can see that's the way to derive this. Okay. ඔගොල්ලෝ දන්නේ නැත්නම් මෙහෙම තමයි හැදෙන්නේ. හරි, මම මේ පරම සත්‍ය කියලා දෙන්න කැමතිනේ. For some students, they might feel this one is a little bit hard, but no need. I'm giving you the actual concept as well as the final summary. I'm just asking you to write down the summary only. And when you take an angle here, when you mark a triangle again, whatever triangle, you can see the coordinates. This one is minus, this is a positive x. So when you take the cos value, the hypotenuse is always positive. Then your cos theta means always, you can remember cos theta here. What's happening? Cos theta is adjacent over hypotenuse. Adjacent over hypotenuse is a positive value. But your sine adjacent over hypotenuse is a negative value. So then your tan also opposite over adjacent, that one, this one is negative because of that tan also negative. හරි, කොහොම හරි ඒක වැඩක් නෑ. ඒක තේරුම් නැතත් ප්‍රශ්නයක් නෑ. හරි, so no need to think about that. Just remember the concept here. Sine negative, cos negative, positive, tan negative. Sine negative, cos positive, tan negative. So this is the, when you take whatever here quadrant, you can identify here all positive, here sine positive, here tan positive, here cos positive. In Sri Lankan terms, how do you memorize that one? Okay, so දැන් පිටරට සුද්ධ ඉගෙන ගන්න ඕනේ. හරි, foreigners ලා when they are learning, they don't know about the Sri Lankan way. High then they are learning this one as all silver what මතකත් නෑ මට. all silver teacups. all silver teacups. හරි, ඒගොල්ලෝ මම තියාගන්න. foreigners ලා all silver teacups. හරි, all කියන්නේ all, s කියන්නේ silver, teacups. That is the way that foreigners are learning this, because they don't know Sri Lankan way, but we have a unique way. We have a unique way. So ඒක හොඳ ස්කෝලයක් අපිට උදව් කරනවා. හරිද? all St. Thomas College. ඒක තමයි අපි ඉගෙන ගත්ත කාලෙත් අපි පාවිච්චි කරේ. හරි, but ඒක දන්නේ නැහැනේ foreigners. They built another variation. Okay, so but in Sri Lankan, what we are going to do, all මෙතන sine, all sine, we are remembering the positive terms. We can mark, we can learn, or we can memorize all the positive sides. So this is all positive. Here only the sine positive. Here only the tan positive. Here only the cos positive. Okay. Here only the cos positive. So I'll erase this one. Now come on, I'll write another one. Then it's easy for me. Hi. So this is the concept that, but how do we memorize this? How do you memorize this? You can take, this is the quadrant. Whatever, if there is an acute angle, then all positive. Here, when there is an angle in this quadrant, second quadrant, sine positive. Then if there is an angle in the third quadrant, tan positive. Then if there is an angle in this fourth quadrant, it's cos positive. So අපි මේකේ මුල් ලකුණු ටික මත තියාගන්න තමයි answer. So we can memorize the all silver tea cups in Sri Lankan way. එහෙම තියෙනවනේ අර හැම එකකටම ලංකාවේ version එක. හරි, all silver tea cups. or ඒ ලංකාවේ තියා තියෙන tea කිව්වනේ අරන්නේ. හරි, foreigners ලා tea තේ වලින් තමයි තියාගන්න හරි. සිල්වර් ටී කප්ස්. ටී බලන්න කොච්චර ලංකාවේ තේ කියන එක යනවාද කියන්නේ. ලංකාවේ හින්දා නෙමෙයි. හරිද? all silver tea cups ඕ අපි මොනවද තියාගන්න all St Thomas College. St Thomas College. හරිද? so all silver tea cups ඕ නිකන් මට හොඳ මතක තියාගන්න තියෙනවා all sin tan cos. all sin tan cos. These are the positive angles. All the other things are negative there. Okay, remember the concept. And then එක හරි වුණ relationship ඉගෙන ගත්තා. So we identify one relationship regarding the sign. We learn the relationship regarding the sign. That means when you take sine, you can see when you take a sine graph, you can see here. So you can see when here in this case 0 to 90 is positive, 90 to 180 positive, first quadrant, second quadrant, third quadrant negative, fourth quadrant also negative. Sine graph. When you take tan graph, cos graph, this is the, you can see me, first quadrant positive, second quadrant negative, third quadrant, this is third quadrant negative, again fourth quadrant positive. බලන්න මේ ඔක්කොම මේකේ පේනවා graph එකේ. So when you take a tan graph, first quadrant positive, second quadrant negative, third quadrant positive, fourth quadrant again negative. Negative values, values. Now we identify the sign. Use a certain pattern, we learn about the sign of that value. That's the sign. Make a sign can be SING. Sign. We learn about the sign of the trigonometry term. Signed of the trigonometry sign positive, tan positive, cos positive, or this is all positive. Okay. So මේ දෙකේ විතරයි sin positive වෙන්නේ. මේ දෙකේ තමයි cos positive වෙන්නේ. මේ දෙකේ තමයි tan positive වෙන්නේ. I told you, I showed you that. In the standard graph you can see it. So now we know about the sign, SING sign. So now we need to identify the, what we call the, we need to identify the magnitude. Now we have a table for the acute angle, for whatever obtuse angle, how do you get the magnitude? This is the pattern. So learn the pattern. So I'll explain the pattern. After that you can use the, for whatever angle you should get the angle. How you can get the angle. These are patterns. I'm not going to teach you the derivations, just a pattern. Learn the pattern. Pattern again no command. Okay. So now the pattern is, you can take these two axes are very important. This is the vertical axis. Vertical axis, what are the angles of the vertical axis? 90 and 270. This vertical axis represent 90 and 270. 90 and 270. Your horizontal axis represents 0 and 180. 0 we can say this is 360. 0, 360, and this one is 180, the value of that axis. This is 90, this is 270, this is 0 or 360, this is 180. I'm asking questions, you can tell me the answer. Now let's take, there is angle here. Okay, let's take, this is the theta. Then that one is okay, doesn't matter, you know that sin theta, cos theta, tan theta, you can use the table and find it. So now let's take, there is angle here. We have angle here. This is the theta, alpha. Let's take, there is alpha. Okay, let's take that one again. Give me 1 second, draw it again. Okay. Hi. So now this is the horizontal axis and the vertical axis. Okay. So now this is theta, that one is okay. You can identify whatever angle in that quadrant, first quadrant. So now I'm marking another angle in the second quadrant. So this is the obtuse angle. You don't know the sine alpha value, but I need to find that. I need the sine 120. So when there is a obtuse angle, always this is the way to get that. This is the way to get the pattern. You can represent that obtuse angle using an acute angle. We need to represent this one using another acute angle. Make a mark on an acute angle hacking. So what we can do for that, we can use the vertical axis or horizontal axis. Here this one, you need to mark this alpha using vertical or horizontal axis. So I would like to take this one. Make gun. So then I can mark this one as theta. So this is acute angle. You know that one is a acute angle. So then I can represent, this is the way to get the answer. Remember that. First thing is, when there is an angle 120 or whatever acute obtuse angle, you need to mark that one using a acute angle. For that you can use this axis or this axis. Let's take this is theta 1 and this is theta 2. Let's take theta 1. I can represent alpha. This is 90 vertical axis. 90 plus theta 1. 90 plus theta 1. 90 plus theta 1. Alpha equals, I can represent alpha in terms of acute angle. Alpha equals 90 plus theta 1. Or I can represent alpha in this way also. Doesn't matter. Theta 2 is also acute angle. Then I am using this horizontal axis. I am using this one. Then I can write alpha equals 180 minus theta 2. Both way are okay. Two methods. No need to do the both at the same time. You can use whatever familiar with you, family for you. You can take theta 1 or theta 2 just to represent the alpha. First thing is you need to find the, they are asking question sine alpha, sine 120. So then if let's take a numerical example. If the alpha is 120, now I need to sine 120. So first thing is you need to represent that one using, so let's say my equation is sine alpha, sine 120, sine 120. I can represent sine 120, using 90, that means 90 plus 30. Or I can represent sine 120, sine 180 minus 60. Both way are okay. So I'm taking a numerical example. I need sine 120. You need to convert or you need to represent that one using whatever axis. හරිද? එහෙනම් තමයි පළවෙනි principle පළවෙනි option එක. You need to represent that one using whatever axis. Then now you know this is sine. This is sine. This is sine second. You are in the second quadrant. This is sine. You are in the second quadrant. Remember the concept. This is second quadrant. Sine positive. You are taking sine. You are asking sine. If it is sine second quadrant, definitely that one is positive. And this one is positive. This one is positive. Sine is positive. Then we need the magnitude. So remember that when you are using the vertical axis, to represent the acute angle, then always your sine term change. Sine can term change cos වලට. Sine term change cos, you can mark the angle directly 30. Okay. So since this one we are taking sine, you can decide this symbol. මම symbol කියලා පාවිච්චි කරන්නේ නැත්නම් දෙකම pronunciation same. This is sine. This is also normally we are defining as SING, but I'm taking that one as symbol. Otherwise you will get confused. According to my pronunciation, you can't differentiate it. Okay, so මම අපෝ කියනවා first thing you need to know identify here they are asking sine 120. So then this is a pattern. Remember that sine 120, I can write sine 90 plus 30. or 180 minus 80 doesn't matter. So now we need to take the sine angle. So sine, the symbol is positive. The symbol of that one is positive because that one is second quadrant sine. Second quadrant sine value. Then if you are using 90, remember that if you are using this 90 or the vertical axis, or the vertical, remember the vertical axis, not the 90 vertical axis. If you are using vertical axis, that means either 90 or 270. Either 90 or 270. If you are using vertical axis, always term change. Always term change. Always term change. Angle you can directly write. Doesn't matter whether it is positive or negative. Again, no need think about the positive or negative. Just write the direct term, direct angle. So then you can mark the final answer. You know the cos 30. Cos 30 means root 3 over 2 is positive root 3 over 2. Positive root 3 over 2. Then in this method is also applicable. But in this way, if you are using 0 or 180, first identify the symbol. So this is second quadrant sine. Then you can mark plus. It's plus. But if you are using 180 or the horizontal line, horizontal axis, then your term doesn't change. Term doesn't sine my. Angle make anything no need to think about the plus or minus, it doesn't matter, just write 60. Just write 60. So you can take sine 60 means again root 3 by 2. Root 3 by is same answer. I told you using whatever way you can get the answer. You can get the answer. So always there is a pattern. Remember the pattern. So what is the pattern? You need first the given angle you need to represent using the vertical axis or the horizontal axis. Vertical axis or the horizontal axis. This is the pattern. If you follow any standard method, I'll show you. So fundamental trigonometry for physics. Google so you can see this is circular quadrant ASTC rule. When angle exceeds 90, the trigonometric sign depends on the quadrants in which the term arms lies. The Cartesian plane is divided into 4 quadrants, spinning counterclockwise from 0 to 360. All silver teacups is the rule. So here you can see all first quadrant all turn positive, then second quadrant sine positive, third quadrant tan positive, fourth quadrant cosine cos positive. Then formula for symmetrical reduction. Symmetrical reduction. There is a we need to get symmetric. That method is known as symmetric reduction. Symmetric reduction across quadrants. So I told you, if it is second quadrant, you can write that we need to represent that angle using 180 or 270. If you are using 180, term doesn't change. Term doesn't change. Okay, term doesn't change. What is taking on a term doesn't change. So you can write like that. Okay. So so you can represent again, you can represent here. There is no need to worry about that one. Here you can this is pi by m is 90. Okay, you can represent this angle using 90 or 180. You can represent whatever in the second quadrant using pi by 2 means 90, pi means 180 in radian. So 90 plus 30 or 180 minus 60. I did that. So here also you can represent same way. I mean you can represent the angle here using this axis 180 or 270. Okay, this angle you can represent 3 by 2 and then 270 or 360. 360. 2 pi means 360. Okay, so then we'll do some. I mean, we need to note down this one. So I did a sample calculation. So let's write down that one as general method. So what is the general method? First, what we need to do? We need to represent that one using x-axis or y-axis, that means 90 or 180. එක හදාගන්න ඕනේ ඉස්සෙල්ලා. You need to do that one. Then after that, remember the concept. After that, first thing is, this is general method. Whatever quadrant, this is general method. You can represent sine or whatever thing. So you can represent sine or cos or මොකක් හරි අපි කියමු sine as example. Sine, if you represent 90 or the vertical axis. හරිද? For example, let's do that one here for the first quadrant. For the first quadrant, let's take I need the sine alpha. I need the sine alpha. Here in this first quadrant, I need the sine alpha. I can write sine alpha. Okay, mom, I'll write here. I'll write here. So here, this is my first quadrant. Then I can write sine alpha. I need sine alpha. Then I can represent sine 90 plus alpha. Okay, then if you are using 90, I told you, if you are using, and first thing is you need to note down or need to identify the symbol, whether it is positive or negative. So now you are in the second quadrant. Second quadrant sign is positive. Second quadrant sign is positive. So because of that, this is positive. But you represent that one using 90. 90 means term change. Term change. Term is changing. The term is changing. Because of that 90. Because of this 90. Because of the 9 term change. Here, why we are selecting positive? Second quadrant, sign positive. Second quadrant, sign positive. We are taking sign, second quadrant, sign positive. And here we are, since we are selecting 90, because of this 90, term is changing. So it becomes cos alpha. So your sine alpha, sorry, not alpha, my bad. You need to represent theta here. Theta 1, theta 1, theta 1, 90 plus theta 1, 90 plus theta 1, sorry, my bad. Hi, not 90 plus alpha name, sorry, 90 plus theta 1. So because of that, this one becomes plus plus cos theta 1. Example then. So I'll write the example here. Example is, if you need sine 120, you can write sine 90 plus 30. Since you use the vertical axis, you can write it's cos 30. How do we determine the symbol? It's second quadrant sign positive. Okay. Then other method is, this is you can remember one method. You can remember the 180 only. So if you are using that axis, sine 1, this is a pattern, okay? 180 plus theta 2 plus minus theta 2. Then again, this is sine first quadrant. So I can use this first quadrant positive. Then term doesn't change. Here remember, the term is not changing. So sine theta 2. Okay. So in this case, remember the concept. Here you are using 180. Because of that, term is not changing. Term is not changing. Same term you can write. ඔයගොල්ලෝ physics කරනවා කියන්නේ අප pattern අඳුරගන්න පුළුවන් වෙනවා. You need to memorize the patterns. This is just a pattern. Term is not changing. So you can write the same angle here. Example sine 120 equals sine 90 plus 180. මේක තමයි පරම සත්‍යය. හරි. පරම සත්‍යය කියන්නේ pattern එක. This is the fundamental truth about this pattern. Pattern එක. So 180 minus theta 2 equals then what we can do here, plus sine theta 2. I mean, my example, sorry, I am writing the same thing again. So here you can write 180 minus 60. 100 minus 60. Because of that, this one becomes sin 60. Sin 60. This answer also plus root 3 over 2. This also plus root 3 over 2. ඔගොල්ලෝ මතක තියාගන්න වැඩි වගේ න always remember the 180. It's easy for you. 180 term doesn't change. If you are using 180 as a reference, your term doesn't change. It's easy for you. Always use the 180 there. වැඩි ලීසින්. හරි. 180. 180 means horizontal axis. Horizontal axis. Use the horizontal axis. Use the horizontal axis. Okay. Use the horizontal axis then. So then doesn't matter. I mean, you can use both way. Only difference is your term doesn't change. Here term is changing. If you use 90. So your sin 120 is root 3 by 2. So now I need the cos 120. Cos 120. I need cos 120. Let's take I need cos 120. Cos 120. How do you do that? First, identify the relationship. Let's take I'm using 180. Was 180 minus 60 kiloohm. So now when you simplify this one, this is not a simplification, just another way to write it. So now I am going to simplify. So cos second quadrant negative. The negative comes with the second quadrant because it's second quadrant. So term doesn't change. So cos matamai cos 60. If you use the other way around, cos 120, you can write cos 90 plus 30. If you are using 90, always your term changing. Still you can see this is second quadrant, positive, sorry, negative, cos negative, sin positive, cos negative. Then you can write cos. Here remember that your term change. If you are using 90, term changing. That is sin 30. Both are providing half, minus half. So, but future reference, for the future case, I will take the 180. It's easy for us. Both are fine, both are possible, but use this axis, horizontal axis. So now you know how to convert. So let's take now I am asking cos 150. Cos 150. So you can represent cos 150 equals cos 180 minus 30. Cos 180 minus 30. So this is second quadrant. Second quadrant, cos 180 minus 30 means term doesn't change. So cos 30 minus cos 30. Minus cos 30. Minus cos 30. Minus cos 30 minus root 3 to root 3 divided by 2. Root 3 divided by 2. Okay. So you can write if you want cos 150. I can write directly cos 180. I am using 180 minus 30. That one is cos 150. Sorry. Minus cos 30. Second quadrant minus, using the simplification method, I can write minus root 3 by 2. If you use a 90, same way, but term doesn't change. Term is changing. So let's take I need tan 135. Remember that. So here I told you if you are using 90, if you are using 90 axis or 270, if you are representing this one, short note if you are representing this axis, if you are representing this axis, angle use so then remember that your sin is turning into the cos. Cos is converted into the tan. Cos is turning into the sin. Sin. Tan is converted to the cot. Okay, cot. That means here if you are representing this one, let's take sin alpha equals sin. Here let's take this is alpha. This is let's take theta. This is theta. Okay. So then I can write sine alpha equals sine 90 minus theta, 90 plus theta, sorry, 90 plus theta. Then I can write sine alpha equals plus cos theta. මම කියන්නේ 90 ගාව ගන්නවා හරි. ඔයගොල්ලෝ වැඩේ complete වෙනවා මේ කියන්නේ. Cos theta plus cos theta. Yeah, I mean, if someone had this kind of problem, then I need to answer for that person also. Sine එක cos වෙනවා. If you are using 90, then let's take cos alpha. Then I can write sine 90 plus theta. And then I can write that one is cos alpha equals, here is second quadrant minus here, sorry, my bad, we can cos my have because it's still cos. Then now I'm converting, now I'm simplified. This is not a simplification, just a rewritten, I mean just a rewriting, not a simplification. So cos alpha equals, here second quadrant cos becomes sine theta. Okay, so if you use the tan, if you want to find the tan value, tan alpha, you can write tan 90 minus theta. Okay, so then tan alpha, if you are representing 90, okay, 90, this is tan in second quadrant. Tan in second quadrant is minus cot theta. Cot theta done nahe. So then you can convert this one again into minus 1 over tan theta. Cot means 1 over tan, because we don't have a cot value. I mean, there is a, I mean, you can see in your tan table, there is a cot table also. Yati indam mark කරලා තියෙන cotangent කියලා mark කරලා තියෙන cot table. Okay, so like sine converting to cos converting sine converting tan converting to cot. Remember the concept. If you are using 90, but mama then going to cure, you no need to use 90, use the 180, then term doesn't change. I just explained this one for your, I mean, for the completeness. Okay, so this one becomes cot, this one becomes sine, this one becomes cos if you are using 90 or 270. Same thing for the 270. අපි මොකක්ද angle එක ලියාගත්ත කියමුකෝ 270 plus theta 1 කියලා. I mean for this kind of alpha obtuse angle. Then again the same thing if you are using 270 vertical axis, but now I'm not going to use vertical axis, I'm always using the horizontal axis. Then it's for you and also for me. I can use whatever I want, but as a general idea you can use the horizontal axis. And then let's say I need tan 135. Tan 135. Tan 135, I'm using that 180. So let's take tan 180 minus 45. Then I told you if you are using 100, term doesn't change. But this is second quadrant minus tan 45. Tan 45 is 1, so it's minus 1. It's minus 1. So use the 180 for your calculation also, then easy for you. Term doesn't change. Tan, cos. So not this one here. Tan, cos, sine. If you are using here 180 or 360. Okay, so I did some calculation, you can see. හරිද? Okay, this is the concept. Remember the concept. For whatever obtuse angle, you need to represent that one using vertical axis or the horizontal axis. Vertical or the horizontal. If you are using, I mean, now forget the vertical, take the horizontal only for your reference. So then now what we can do, you can represent that one using the horizontal axis. Just remember that one only. Then your term doesn't change. Just identify the quadrant, and based on that one you can decide whether it is positive or negative, or positive or negative, and you can simplify. second quadrant. Now we work with the second quadrant. Let's move to third quadrant. Third quadrant. Third quadrant එකට යමු. So I think is it clear? ප්‍රශ්න නැහැනේ. So now let's move to I mean no need to think about the vertical one now. So now I'm going to the third quadrant. Let's discuss some question with the third quadrant. සම්පූර්ණ යහකට යමු. හරි, okay. I'm going to the third quadrant. So let's say there is an angle here. I need to find the sine value of that one. So now I'm going to use the 180 only. So I can represent alpha in terms of 180. So let's take, I need sine alpha. So then I can write sine 180 minus theta. So since I'm using sine 180, term doesn't change. Term doesn't change. Minus me plus, sorry, plus 180 plus theta. Term doesn't change. Term doesn't change. And now this is third quadrant. This is third quadrant sine negative. Third quadrant sine negative because of sine theta. Minus comes with the third quadrant. Third quadrant sine negative. Third quadrant sine negative. First, okay. So as example, now you can see what's happening. So let's take some numerical example. Then easy for you. I'm product make 270 use kala. So let's take this is because I didn't use the 270. So 270 was the same idea. So let's take this one is theta 2. So I can write sine alpha. But for the completeness I will explain. Sine, I can write 270 minus theta. Since it's second quadrant, third quadrant, sine minus, that one is based on the second quadrant. Sorry, third quadrant sine negative. Okay, so this is 270, definitely term change. So sine cos then cos theta 2. Cos theta 2. That is the way to get the pattern. That's the way to get the pattern. But no need to think about that vertical axis, take the horizontal axis only. Take the horizontal axis only. So learn the pattern with the horizontal axis only. So now you can see I'm not taking the vertical axis now. Hereafter I'm taking only the horizontal axis. So remember the concept now. If you need, let's take as example, I need sine 240. 240. In monoquadrant again, in between 180 and 270. So then I can write sine 240 means 180 plus 60. So it's third quadrant. Third quadrant I'm using 180 always. So third quadrant term I mean minus is minus because third quadrant sine minus, then sine 60. This is the pattern. So the answer is minus root 3 over 2. Minus root 3 over 2. Let's take, I need another calculation cos 200 let's take 10. Cos 210. So then I can write cos 180 plus 30. Then you can write that one is cos again negative. Third quadrant cos negative. Then it's again right cos 30. Then that one also minus root 3 over 2. This is cos 210, right? This is 240. Totally different angles. This is 210. I'm not taking 240. I'm choosing different angles. Then let's take, I need tan 235. 25. 225. I'm taking different cases. Okay. So tan 225, I can write tan 180 plus 45 plus 45. Then I can write plus tan positive in third quadrant. Then tan 45. Then that one equals plus 1. Plus 1. So this one sign is depending on this sign means the symbol is depending on the quadrant. So use 180 for your reference also, it's easy for you. 270 ගාව ගන්න ඕනේ. එතකොට term එක change වෙනවා but no need. So let's take another quadrant, fourth quadrant. Make it one. So this is about the third quadrant. So I would like to get another angle in the fourth quadrant. Here we have beta here. Beta. I can represent again that one is 360 because I told you horizontal axis. This is 180 or 360. Okay, so I can represent this one using 360. This is I am taking theta. This is 360. Use the horizontal axis. This is 180. Okay, so now what we can do? So here I need sine 300. Sine 300. Then I can represent sine 300 using the horizontal axis. Sine 360 minus 60. 60 minus 6, 360 minus 60. Term doesn't change. Term doesn't change, but this is in the fourth quadrant. Fourth quadrant sign is minus. So minus sine 60. Again, that one is minus root 3 over 2. Then I would like to take cos 320. Different angle, different. So then you can take cos 360 minus 30. Then value is term doesn't change. Cos 30 is positive. Fourth quadrant cos positive. Then the value is root 3 by 2. Root 3 by 2. Positive. Let's take tan tan 300. Tan 300 again. Tan 300. Then tan 300 I can write tan 360 minus 60. Again I can write tan doesn't change but is negative. Fourth quadrant tan negative. So tan 60. දැන් හිතට කමක් නැහැ පාඩුවක් නැහැ හරි. Then minus කවදා හරි ඕන වෙන්න පුළුවන්. 3 root 3 by 2. Sorry, root 3. Root 3. Tan 60 root 3. So this is the way to calculate whatever obtuse angle. If you need any like 400 whatever, same thing again 400 you can represent using this acute this angle. Actually so normally learn about that main four quadrants like but most of the A level stuff you need first quadrant and the second quadrant. First quadrant, second quadrant, but if there is a question based on third and fourth, still you know the way to get it. Okay, first quadrant and third quadrant, sorry, first and second definitely you will get first and second. Okay, so but for any other case also now you know. Same pattern, refer the 200, 180. So then term doesn't change. So just you can simplify it easily. You need to check whether it is in the first quadrant, second or third or fourth. It's a one thing. Then you can have a simplification. So no need to think about this internal term. Internally there is a plus or minus. Again, no need to think about this internal one. Maybe a positive or negative. Don't need to think about that one. Just write the given angle in terms of 180 or 360. So then there is an angle here. Then put that angle directly to here. Then the symbol depends on the location where it's in the first or second or third or like that. Hari. ඕක තමයි කතන්දරේ. So now you know the way to convert, or now you know to get a sine, cos, tan for any obtuse angle. Using this 180 and 360 you can get. So no need to use the vertical one, then term change, no need. I mean, on anything. Okay. So okay, summary summary I create a summary. You can see here symmetric reduction using 180. Second quadrant 180. Term doesn't change, so sine 30. Sine theta. Cos minus because of the second quadrant. When you take third quadrant, both are minus because tan is positive. Fourth quadrant, you can see fourth quadrant, you can convert that 360 minus theta directly sine. since this one is the fourth quadrant, is minus, sine minus but cos positive. So tan ලියලා නැහැ, tan එක ගන්න පුළුවන්. So okay. So then these are the values. These are the values. These are the values in radian. Radian වලින් තියෙන. Okay. So මතක මේ කටපාඩම් කරන්න ඕනේ නැහැ. මට මතකත් නැහැ. Sin 120. I mean, if you want, you can memorize. Sin 120 is minus root 3 over 2. Then or else just remember this table. ගොඩාක් මම තියාගන්න අමාරුවෙන්නේ කටපාඩම් කරන්න. But pattern easy. You can memorize the pattern. You can memorize the pattern. Patterns are easy. Okay. So just remember this one for the most of the time we are using this one. For any other angle, you can use the table, acute angle. Okay. So now you know the main angles like this. And after that, what we can do? What we can do, if someone has sine 150, sine 150, you can write sine 150 equals 180 minus theta, 180 minus 30, 80 minus 30, 80 minus 30 equals sine 30. Sine 30 term doesn't change, and since it's the first quadrant, positive, sine 30. Hari? ඒක තමයි pattern එක. Just remember the pattern. If you want sine 180, 80 180, that's easy for you. Remember the 180 values. 180 sine is again equal to 0. This one is again equal to, this is minus 1. You can see when you plot the sine cost graph, you can, if you can remember the graph, then again it's easy. Graph the behavior. That one also another requirement. You need to remember the variation. This variation. You can see here 180 again 0. But in this case, but in this one, you can see 180 is minus 1 for cost value. For cost value. So likewise, you can remember the variation. That's also a very important thing. Remember the variation. And or else I'll give you a chart. So here this one is sufficient enough for your level. Because we say so you can see 30, 45, 60, 90, again 180. That's enough. 270 if you want 270 or 360. This table is sufficient enough. So here this is undefined infinity. Okay. Infinity. Infinity. You can take it's undefined, but it's going to the infinity. Okay, this is the table you need to memorize. So this is in radian, degrees in radian. If someone asks sine pi by 3, sine pi by 3, physics maths sine pi by 3, that means you should know sine pi by 3 means sine 60. Sine 60 root 3 by 2. Okay, but here now what we are doing, we are converting back to the degrees, but as a math students, you should not do that. When you identify, when you observe this one, at the moment you need to know about like root 3 by 2. Practice no need to convert that one, because you are always using radian for a math student. For a physics never make any. In maths, they are always using radian only, not the degrees. Radian only. Your calculations are based on trigonometry, radian only. Okay, you can put degrees, but all the calculations you can see they are doing in the radian. So remember this chart. Okay, so 0, 30, 45, 60, 90, 180, 270, and 3. But all these values you can remember with the variation. You can remember the variation. Variation. Remember these values 90, 180, 270, and then 360. Remember the values of these points with the variation. Remember the cos 1 with the variation. එතකොට ලේසි. හරි මම මේ ඔයගොල්ලෝ ජීවිතේ ලේසි කරලා දෙන්න හදන්නේ. කටපාඩම් කරන්න ඕනේ නැතුව. Remember this variation. Then for 90 cos 0, 0 for cos 0, I mean theta 0 is it's 1, 108 is minus 1, 270 is 0, 370 again plus 1, 360, 270 0, 360 plus 1. Deal. So you can no need to memorize, just but remember these this one. These are regular values, but if you want 180 other things, then you can remember the shape. And if you need any tan value, then divide the sine divided by cos. තව පොඩි දෙයක් කියලා එන්නයි ඉවරයි. හරි trigonometry for A level knowledge. So if you take whatever negative angles, කවුරු හරි negative angle එකක් දුන්නොත්, if you measure negative angle, you can write sine minus theta. You can take the minus out from the theta sine function. If there is a negative sign minus theta, you can take the minus out from the bracket. Right? Sine theta, you can take the minus out. Then cos minus disappear. Minus නෑ. හරි minus තිබ්බ නැති වුණා. Sine එක වෙන්නේ with the fourth quadrant, but no need to just remember this concept. No need to explain. So if there is a minus, but in the A levels you are not getting that much calculation, but somehow if there is a question, we don't know. So tan minus theta, remember that you can take minus again out. So here the concept is for whatever minus angle, for cos, it's disappear. Cos minus theta, you are measuring this direction, it's disappear. Cos minus theta equals cos theta. Tan minus theta equals minus tan theta. Sin minus theta equals minus sin theta. You can take the minus out for sin and tan. But for cos, it's disappear. Minus නෑ. මෙතන තිබ්බ මෙතන නෑ. මුකුත් නෑ. Okay, ඒක මම තියාගන්න ඕන. Okay. තව ගොඩක් දේවල් කියලා දෙන්න තියෙනවා regarding the other mathematical concepts. ඒක අපි ආව දවසක් කරන්න වෙනවා. We'll do another day. Support you day 2, because I need to explain about the way to get the logs, proportional, direct proportional, inverse proportional. And now trig is sufficient enough. This knowledge is sufficient enough for your level. I mean, for the physics student, this trigonometry level is not too much. This is the sufficient, I mean, ample knowledge of trigonometry I gave you today. That's enough for your level. තව ඕන වෙන්නේ නැහැ. ඔය ටික තමයි ඕන වෙන්නේ. Okay. හරිද? වැඩේ පුළුවන් දැන්. So මේ table එක පොතේ ඇඳගෙන පේන තැනක උදේ හවස පොඩ මතක තියාගන්න. හරි? If when I'm asking sin 30 value, හිත උලෝ කහ කහ ඉන්න බෑ. When I'm asking sin 120, not 120, sin 30, I'm asking sin 30, you need to tell me as the half, directly half. Sin 60, root 3 by 2, tan 45, 1, tan 60, root 3, tan 30, 1 or root 3. එහෙම එකපාර කියන්න ඕන. process වෙන්න වෙලාවක් නෑ. හරි? එහෙම වෙන්න බෑ. You should directly tell me. So study that. Study the table. Study this table. කටපාඩම් කරලම තියෙන්න ඕනේ. ඒකේ කටපාඩම් නෙවෙයි. When you are reading, when you are doing the calculation with this, you can identify. තව චූටි දෙයක් තියෙන එකක් කියලා ඉවර කරන්න, then is enough. මට මේක vectors එකක් කියලා දෙන්න පුළුවන්. හරි, vector resolution කියලා එකක් තියෙනවා අපිට. හරිද? So we can do that one, but I'll explain that one here. But I'll explain that one on the Friday also. So let's say there is a triangle. So let's say there is a triangle. Dragon. Let's take there is a triangle. So when there is a triangle, we know this one is x, this one is y, this one is z. I'll take that one as z. So I'm taking this one as theta. So what is the definition of sine theta? Sine theta means x over z. If I subject x equals sine theta, z sine theta. I can write x equals z sine theta. If you take cos theta definition, I can write y over z. Then theta y equals z cos theta. Okay, if you take triangle, you can do this. So there is a method known as vector. In the vector lesson, vector resolution, vector resolve karna. Vector resolution. Resolving vector to into two perpendicular components. So let's say we have something like this 5 Newton. I would like to represent that one is two perpendicular components. I would like to resolve that one in two perpendicular components, two perpendicular values. So you know that after, I mean, we know if there are two perpendicular vectors, you know how to get the resultant one. We learned that vector triangular method, and you know how to get resultant one. If there are two perpendicular vectors, you know how to get resultant one. This is the resultant. I can find that one using the third side of the triangle. If I mark the vector triangle. So now my goal is, if you know the resultant, I can convert again back to the two vectors. Let's say there is a one vector, I need to convert that opposite and I have a resultant. Now I need to get the components. Earlier we did, these are two vectors, the way to get the resultant. So now if the R is given, I need to identify the component. These things are known as components. Components. Horizontal component, vertical component. Horizontal component, vertical component. Horizontal and vertical components. Remember the concept. Okay, remember the concept. So now this is the concept, this is the idea, it's very simple idea. If the angle is, so you can see in this, using this triangle, we can find the x and y using this triangle. You can find the x and y, so let's say now we have the resultant. I need to find the x and y. So for that we can use the triangular method again. So let's say this angle is theta. So there is the one vector is r. There is one vector r. I need to find the horizontal component, horizontal line, and this is the vertical line. So here, if you want to find horizontal, always get r cos. Here, theory. This is the pattern again. Pattern is, if you want to find the component which is contact with the angle, the component which contact with the angle, contacts with the given angle. Given angle always get the cos product, the cos component. This is the component which contact the angle. Because of that, you will get the cos. We can write r cos theta. This is r cos theta. The perpendicular one, I mean, this is the angle theta, and other one definitely becomes r sine theta. Simply, if it is r, let's say this is 5, then this is 5 cos theta. This is 5 sine theta. 5 cos theta, 5 sine theta. Remember the idea? Okay. Component which contact with the given angle always get the cos. So here you can see, when you take this z cos theta is the y, z sin theta is the x. Better resolution. I'll give you the summary. I'll give you the summary. So මේක ලියාගන්න එපා. I'll give you the summary. So this is the what you know, what you need note down, vector resolution. Vector resolution. Okay. So when you take whatever vector f, so this is the theta, given angle theta, I need to convert this one into two perpendicular one. Meaning tani දෙන්නේ perpendicular දෙන්නේ දාගන්න ඕනේ instead of this f. So then I can write this one. This is the side, or this is the horizontal one is the one contact the theta. So then because of that, this one becomes the cos component always, r cos theta. This one becomes r sin theta. Let's take, there is another one with the vertical axis. There is another force given with the vertical angle. Then you can mark two perpendicular component. Instead of this f, I can mark f cos alpha downwards, f cos alpha, f sin alpha. The side of the vector component which contact with that given angle, then you can mark the cos, f cos alpha, f sin alpha. The side, the component which contact the given angle, get the cos, f cos alpha, f sin alpha, f cos theta, f sin theta. But always remember the direction, mark the direction also. Here this one is vertically upward. So you can see my pen, the tip of the pen is directed to that direction. So f cos theta. This one also horizontal right side. This one vertically upward. But here since the arrow is downwards, you can see f cos alpha, vertical one also downwards. F sin alpha, this one is horizontal left side. Vector resolution. That one is also based on some trigonometry relationships. So I'll explain that one on the vector resolutions also, but for the trigonometry part, you can just write this one also based on the vector diagrams. I mean the trigonometry. When you take whatever angle here, theta, this is x, this is z, this is y. We can add the cos relationship, y equals z cos theta, x equals z sin theta. This is about the trigonometry, sin theta relationship and the cos theta relationship. Okay, this is the theory background, and this is the final thing you need to know. Okay, I think we did around 3 hours today, but we learned all the required trigonometry concepts. Physics for physics you need all this stuff only. For maths you need more. Okay, so I'll stop at this point. If you have any question, you can ask. You can put a comment there. Comment එකකින්ම දාලා ගන්න ඉතින් හරි. Then මේ අලුත් channel එක in the future you will get some recordings using this one. ඉස්සරහට මේවා recordings එහෙම making යයි ගොඩක් වෙලාවට. Not recordings, the live sessions, live paper discussions. So then I'm using this channel, so you can get the notification when there is a live program. So you can subscribe, and also you can comment about the today's session. Okay, so create your own note. If I didn't give that much time to write down, so you can rewind and stop the video and create your own note. Hari. If you want, I'll share this small one. This is the final summary. I can share this one to the group. This one only the it's only 2 page. What is sine, cos, tan? The equations are not there. I explained some sine square theta plus cos square theta 1. But those equations, it's very important. We are always using, not always, most of, I mean, for different equations we are using those. Sin squared theta plus cos squared theta is 1. Not hambe isarahata. This table, and finally the circular quadrants. මේක ඇති දෙයක් නෑ හරි. ඊට වඩා මම කියලා දුන්නා ගොඩක්. Okay, so then after that we came out to some algebraic system equations. I think you know this stuff in this is the new thing. Today I did a new thing for you. You don't know about that one in the O levels. That's why I took more time for that to discuss, because you are not familiar with those theories. You are not familiar with those trigonometry theories. That's why I took more time, but I will do another session next day. But for the vectors, this is enough. So now I need to explain about the like some what we called binomial expansion. Hari, binomial expansion, quadratic equation, simultaneous simplification, then logbook, logarithms, then indices, finally proportional marks, and the graph. Different types of graph. Y equals mx, y equals mx squared, then y equals what's happening, xy is a constant. Different shapes, you should know about different shapes. So let's do another supportive session next day. So I'll stop at this point. So you can create your trigonometry note based on the today session. You don't have that much work currently, so you can improve your mathematical skills these days, and then no need to worry about that one again. Because now when you are doing linear motion, vectors, linear motion, this week we are doing vectors. By next week we can, this Friday we are doing vectors. Okay, by next day we can start the linear motion. I mean our main Friday. So this is, today is the 30th of June. I'm talking, this session is in 30th of June. So you will get that. This week we are doing the vectors, and second week of July we can start the linear motion. We'll see. And when we start the linear motion, you need to know about that calculations. I mean, sometimes I'm also doing a little bit fast, so yeah, that's okay. Trigonometry but අපි බලමු ඉස්සරහට binomial expansion. So our normal class day, our normal class day is Friday 8 p.m. If there is someone new, you can join with us, AFE6. The links are there in the Telegram. Links are there in the ap.lk site. You can access the ap.lk sites or contact us. There is a Telegram channel. All the materials, the updates, notice, those things are delivered through the Telegram channels. And okay, so I'll stop at this point. Then see you guys on the next day. So join at 8 p.m. on this Friday. We can finish the vectors. Okay then, see you. Bye.